Hi guys, I Rakesh Salreja welcome you all to Byjus exam prep platform. The GATE 2024 examination were conducted, the answer keys were released, challenges were posted by the students, and then final updated answer keys were released. So in this video you are going to find the complete detailed video solution with description of all the 65 questions of electronics and communication engineering that were asked in the GATE 2024 examination, so that in one single shot you see all 65 questions with the solution, what is the type of questions came up, how to approach them, and what can be expected in the upcoming years. Okay, so before I start with first question, let me give you a quick update about how the distribution was this particular year. Okay, so control system, we saw 2 questions of 1 mark, 3 questions of 2 mark, totaling 8 mark, and as expected, control system usually comes for 8 to 9 marks for ECE. Digital 3 question 1 mark and 4 questions for 2 mark, making it total 11, including 1 question of COA, computer organization architecture, but that was very fundamental, that was 1 marker. I will discuss that also. Logical question mostly it was. So this is little bit on high side because around approximately 9 is the digital circuit weightage, but it's expected, it's nothing out of the blue, not very much extraordinary as well. EDC this time was pretty dominant, and there was a good level of questions from EDC that came up. Okay, 2 question 1 mark, 5 questions straight away 2 marks with a good level of questions, so 12 marks straight away to the EDC. Okay, along with that, let me first come to the analog. So 4 questions of 1 mark, 3 questions of 2 mark, 10. Analog was also on a moderate to a good side. Okay, so as always expected, EDC and analog can almost compromise 20 marks. So yes, it is slightly more than that, 22 marks. Okay, coming to network theory, the weightage of network theory was relatively lower. Usually again it is 8 to 9, but this time it is 6 marks. 2 question 1 mark, 2 question 2 mark, it made it to 6. Okay, yeah, now coming back to signals. Okay, signal and systems questions were seen. Okay, and including a question of sampling and all, which students challenged also. We'll discuss that. So overall it was a decent paper of signal and system. 2 question 1 mark, 4 question 2 marks. Okay, total 10 marks for signal and system. Decent one, 9 to 10 marks is expected from signals. Communication also more or less around 10 to 12 marks is expected. It is 11. 5 question 1 mark, 3 questions of 2 marks, making it total of 11. Okay, with some good questions in communication that Sakit sir is going to discuss with you. Electromagnetics, 2 questions for 1 mark, 3 questions for 2 marks, making it total of 8 marks. So electromagnetics usually 9 to 10 was the pattern coming up. This year it is 8. Mathematics, 3 questions 1 mark, 3 questions 2 mark, making it 9. Now you might be wondering why it is 9. Usually mathematics they should call it as 13 because they fixed it at 13. So as per ISC point of view, it would be 13 only. I'll tell you what is there in the mathematics. The point in mathematics actually is, okay, the point in mathematics actually is there are some questions, okay, which you may put in mathematics, which you may also put down in electromagnetics or in signals because they are related. Okay, so that is the reason we can't exactly fix the weightage, especially in ECE branch. Okay, so a general aptitude is as always fixed, 5 question 1 mark, 5 question of 2 marks, 15. Okay, let's get started. So we'll go in the flow. First we shall get started with aptitude questions, then we'll go to maths, and then we will jump to technical. Okay, because and this is the pie chart of the same distribution, in the form of percentage, okay, that we have highlighted here, right? So let's come to the first question here. Starting, as I told you, let's start with aptitude, then maths, and then let's go to the technical. Okay, so for a real number x which is greater than 1, 1 upon log x to the base 2, 1 upon log x to the base 3 plus 1 upon log x to the base 4 is 1. What should be the value of x? Okay, so pretty simple one only, because 1 upon log x to the base 2, okay, 1 upon log x to the base 2 can be reversed, because whenever you have a case, log b to the base a can be written as log of a to the base b. Okay, if you exchange the number and the base. Okay, so on this idea I can write down this expression as, okay, log of x to the base 2 I'll write down log 2 to the base x. Similarly, another number will be log of 3 to the base x, and it's good, we're getting the same base x. Similarly, third number will be log of 4 to the base x, and this is total equal to 1. Okay, now because it is the same base x, so log a plus log b is log of ab. Okay, so let's apply the property, and hence we shall get log of 2 into 3 into 4 to the base x is equal to 1. Log of 24 to the base x is 1. So what shall be the value of x? Okay, x should be equal to what? X should be equal to basically 24. Log a to the base a, that cancels, and that should be 1. Okay, right. So x is equal to basically 24 is the correct answer, option number B. Okay, moving ahead to the next question. Number 2 here. PQRST have launched a new startup. 2 of them, reasoning arrangement questions, basic reasoning question. 2 of them are siblings. Okay, the office of the startup has just 3 rooms. Okay, all of them agree that the siblings should not share the same room. Okay, so 2 of them are siblings. The persons are PQRST. Okay, and siblings should not share the same room. SNQ are single children. If SNQ are single children and the room allocations shown below are acceptable to all, these 2 allocations are acceptable to all, okay, then which one of the following given option is siblings? इनमें से siblings कौन सा है? S and Q are single children. That simply means that S and Q do not have any siblings. Right? If they are single children of their parent, they cannot have any sibling, any brother or sister, because they are the single children. Okay, so who may be siblings? Who are the possible options left? P, R, T. 2 of them can be sibling because S and Q cannot make a sibling pair. Okay, so P, R, T. Okay, so possible pairs are either PR or either PT or either RT. Okay, now siblings, okay, should not share the same room. ये बोला है. Now you are given PR. PR, this is acceptable to all. मतलब PR cannot be sibling because this is acceptable. Okay, so PR cannot be sibling. PT नहीं है. RT is also a combination in room acceptable to all. So the only answer is PT. So who are the siblings, dear? PT. Basic. Okay, just puzzling. It's a basic puzzle question. Moving ahead to the third question, the greatest prime factor of 3 की power 199 minus 3 की power 196. Okay, out of this clearly what can be taken common is 3 की power 196, and then I am left with 3 की power 3 minus 1. This is equal to 3 की power 196 into 27 minus 1, 26. What can be the greatest prime factor? Definitely it is factorized in 3 power something. 3 is a prime factor, but 26 can still be broken as 2 into 13, and 13 is also a prime number. Okay, so there are 3 prime numbers. You have factorized it into 2 की power 1, 13 की power 1, 3 की power 196, but the greatest prime factor is 13. Okay, because 13 itself being prime. Okay, done. 26 was a composite number further broken into 2 into 13. Next one, ये भी simple logical question था, again 1 mark. Let's complete this 1 markers first. Okay, so what is the next question, dear, coming up? Okay, 5 years ago, the ratio of Aman's age to his father's age was 1:4. Okay, and 5 years from now, the ratio will be 2:5. What was his father's age when Aman was born? 5 years ago, the ratio of 5 years ago, let's go back. Okay, the ratio of Aman's age to father age. Okay, so now let us say the Aman's age is A. Okay, so 5 years ago, it would be A minus 5. Let us say the father's age is F. Okay, so 5 years ago, both are, less in age by 5 years. Okay, and this ratio 5 years ago was 1/4, right? 5 years from now, so 5 years later, that means, okay, the ratio would be, so 5 years later, Aman's age would be A plus 5, father's age would be F plus 5, because A and F, I have taken the age and the present. Okay, and this should be equal to 2/5. This should be the 2/5. Okay, now, what is the father's age when Aman was born? So one relation we can obtain from here. Okay, what is the relation I can obtain from here? 4A minus 20 is equal to F minus 5. That is one relation. Okay, 4A minus 20 is F minus 5. Okay, and one relation from here, cross multiply 5A plus 25 is equal to 2F plus of 10. Okay, so 5A plus 25 is equal to 2F, and F can be substituted. Okay, F can be substituted. Okay, and what is the value of F that can be substituted from here? That is 4A. Okay, 5 and 20 cancel karenge, so 15 will be left. 4A minus 15, that is the value of F I substitute here, plus 10. Okay, so 5A plus of 25 is equal to 8A. Okay, minus 30 plus 10. Okay, so that gives me 3A. Let's solve this simple equation. Okay, this is minus 20, that goes there, 45. So Aman's age is currently 15, 45 by 3. Acha, then what about the F? If Aman's age is 15, okay, F is given by 4A minus 15. Okay, so that becomes 60 minus 15, 45. Okay, now when Aman's age is 15, right now, father's age is 45. Okay, what was the father's age when Aman was born? Okay, so when Aman was 0, okay, matlab was born means just born means age is 0. Okay, the father will also be, this is 15 years back. The father age would be 30. The answer would be A. My answer would be option number A. Clear everybody? My answer should be the option number A. Done. Next question, guys. A basic word meaning question from verbal. Let us not discuss verbal. Okay, anyways, there were very less questions on verbal. Probably word meaning में एक ही question था. Okay, so if denotes the increasing order of intensity of word. Okay, charm, enamor, bewitch is analogous to bored, jaded, and weary. You can note down this option. Correct answer will be option number B. Okay, chalo. Now let's come to the next question. 2 markers. 2 identical sheets A and B of the dimensions 24 cross 16 can be folded into 2 halves using 2 distinct operations FO1 and FO2. So what are these operations FO1 and FO2? ये देख लेते हैं. Okay, can be folded into half using 2 distinct operations. What is FO1? The axis of folding remains parallel to the initial long edge. FO1, axis of folding remains parallel to the initial long edge. And in FO2, the axis of folding remains parallel to the initial short edge. Okay, whatever is the initial short edge. If sheet A is folded twice using FO1 and sheet B is folded twice using FO2, what is the ratio of the parameters of final shapes of A and B? Okay, where the 2 sheets are initially identical, dimensions 24 cross 16. 24 cross 16. Okay, so if I start with the sheet A, okay, if I start with the sheet A, 24 cross 16, that is what is mentioned. 24 is the bigger one. Okay. Let's say this is 24, let's say this is 16, and sheet A is folded twice using FO1. What is FO1? The axis of folding remains parallel to the initial long edge. Okay, this is the initial long edge, right? 24 is the initial long edge. Okay, so axis of folding should be parallel to it. Okay, so I'm starting with the sheet A, and the axis of folding that you have to take, dear, is the axis of folding that you have to take is parallel to this initial long edge. Let's take the axis as from the midpoint. Okay, so now you have, this is the axis of folding. So how do you fold? You fold it down. Okay, you have to fold it down. Okay, and then you have to fold it one more down. So when you apply twice FO2, okay, let's not apply one by one. Dekho, FO1, when you apply it twice. Okay, why I am applying in single step? Because every time you have to fold along this axis only. Okay, so when you do the first time folding, this will become 8. When you do it folding again, this will become 4. This is unchanged. This is unchanged. Okay. So what is going to be my new obtained sheet? What is going to be my new obtained sheet? Have a look into it. Okay. This remains to be 24, but this is 16. Divide by 2. Okay. Further divide by 2. So that is total 4. Okay. Okay. 8 by 2, 4. Okay, now what is the parameter here? The parameter here is twice parameter of a rectangle, twice into length plus breadth. Okay, so we will do the calculations. Chalo abhi likh hi dete. So this is 28 into 2, 56. This part is 56. Okay, now FO2 to be applied. Okay, to the sheet B, but sheet B is identical to this. Okay, the sheet B is identical to this. Okay, now coming to sheet B, but in the FO2 operation, the axis of folding is parallel to the initial short edge. Okay, this is the initial short edge, और यही axis fix रहेगा. After, you know, maybe after first folding, the initial and the short and long edge exchange, but no. Okay, my parallel will remain fixed. Okay, parallel to the initial short edge. Okay, so now this was 16, this was total 24. Now this time folding along this direction. So now I am going to apply what? FO2 twice. Okay, so first this 24 becomes half, only 12. Then this 12 becomes half, only 6. This 16 will remain as it is. This 16 is going to remain as it is. The 16 is going to remain as it is. Okay. This is 16 and this becomes 24 by 2, again by 2, that is going to be 6. What is the parameter now? Twice 16 plus 6. Okay, that is 22, 22 into 2, 44. Okay, so what is the required ratio? Okay, parameters of the shape, final shapes of A and B. Okay, so that is 56 and then divided by 44, cancel by 2 or cancel by 4. So this should be how much? 14 and this is 11. 14 by 11 should be my answer, dear. 14 by 11 should be my answer. Okay, that is option number D. 14 by 11 is my correct answer, option number D. Let's move ahead to the next one. Number 7. Simple one, okay, but 2 marks. simple one but yet 2 marks, right? क्या बोला यहाँ पे? Examples of mirror and water reflections are shown in the figure below. Okay, an object appears as following image after first reflection in mirror and then reflection on water. What is the original object? So this is the reflected object. But anyways, okay, reflection of an object, when you again see the mirror, you see the original object, na? Reflection will cancel each other. Okay, so basically let's again reflect it. Okay, maybe in a mirror and then in a water. Yeah, you can reverse that also. That's not going to affect. Okay, we all know that, but they have given reference also. We know that water reflection is the reflection about horizontal axis. Mirror reflection is the reflection about vertical axis. Mirror is reflection is like y-axis reflection, folding along y-axis. Water reflection is like folding along x-axis. Okay, but they have given that for clarity. अगर नहीं होता, then also you should know what is mirror and water image. ठीक है जी, चलो. So now first let me take its mirror image. Okay, so mirror image, what will happen? Mirror image, I am telling you, folding around the y-axis. So whatever is on the left will be copied to the left. So we start with the folded 4 first of all. What you are going to see first of all is this 4 folded. Okay, now you will see this 2 folded. Left to right. If it was opening to the left, now it will go to the right. Then there comes a dot. Okay, and then this 5. Okay, the top is opening to the right. ये reverse हो जाएगा ना. And now it will look like this. This is what is the reflected 5. This is what is the reflected 5. Okay. Okay. Now let's consider, this is mirror. Now let's consider water image of this. Okay, water image means upside down. Okay. It means upside down. So this and this top portion will come here. Okay, my answer should be starting with A or C. That is pretty much clear. Dot to last mein aayega. My answer is A, but let us still complete this. Okay, just fold upside down. Okay, then the dot comes and then this segment will come. Top wala segment will come here. Okay, look into this. Perfect answer is option number A. Okay, the very correct answer is option number A. Okay ji. Simple one for 2 marks. Simple analysis question. Number 8. The bar chart shows the data for the percentage. Okay, a bar chart question here. DI data interpretation. The bar chart shows the data for the percentage falling into different categories based on body mass index, that is BMI in 2003 and 2023. Okay, based on the data provided, which one of the following options is incorrect? Which one of the following options is incorrect? Okay, क्या बोला है ऑप्शन में? The ratio of the percentage of population falling into, देखो, now they have clearly mentioned. Okay, if the diagram maybe is not clear to you, let me make it very clear to you that this slightly dark orange, this is 2023, and this light one, light color, this is 2003. मतलब ऊपर वाला for every, this is the bar chart for obese. If this is the percentage for obese, this is overweight, this is normal, and this is underweight. Okay, these are the 4 categories given to you. ठीक है, and along with the percentage of population. Now the ratio of percentage of population falling into overweight category, okay, to the percentage of population falling into normal category has increased in 20 years. Okay, the ratio of percentage of population falling into overweight, okay, to the percentage population falling into normal category. ठीक है, so in 20 years. तो देखो, सबसे पहले they are asking the percentage of overweight to normal. Okay, overweight to normal. Overweight to normal. Has it increased in 20 years? So when I see 2003, as I told you, the second wala. So overweight, this percentage is 25. Okay, this percentage is 25. Normal. Okay, this is normal and this is 50. This is 50. Okay, and now it has changed. Okay, let's look into 2023 then, क्योंकि incorrect choose करना है, जो भी incorrect आएगा वहाँ stop कर देंगे. Okay, now we have to see that in the 2023. That means this the more orange one. Okay, so this is overweight, that is 40%. Okay, and this is normal, that is 30%. 40 by 30. Now, has it increased? No, has it increased? Okay, yes, it is increased, correct. 25 by 50 is 1 by 2. This is 4 by 3, greater than 1. That has definitely increased. Okay, the percentage of overweight people have relatively increased as compared to normal. Okay, because of change in our fooding habits, definitely. Okay, so this is correct. We have to identify the incorrect statement. Okay, ये तो true है. Okay. Now, the ratio of the percentage of population falling into obese to the percentage of population falling into normal has decreased. Now, we need to check the ratio of obese, okay, to the normal. Okay, obese, ये ऊपर वाला आएगा first 2023. Okay, now I am checking obese by normal. Obese by normal. Okay, so 2003. Okay, obese. This is how much? 15%. Divide by normal. Okay, normal. Normal तो ये लिखा ही हुआ है ना 50. That denominator already I know. Now same thing, obese in 2023. Okay, it is 50. It is sorry 25. Okay, it is 25 divided by ये same denominator 30. Now has it decreased? They are asking has it decreased? Okay, has it decreased? Okay, 15 by 50, 25 by 30. Is it decreased? No, no, let me check it out. No, it is not decreased. Okay, it is actually increased. 15 by 50, there is a 3 by 10, 30%. Okay, it has actually increased. It has actually increased. This is an increase and they say decrease. So this is incorrect. Answer should be option number B. Okay. Now option number C, let's just check the other options also. The percentage of population falling into normal category has decreased. Only normal वाला check करना है. Okay, in 20 years, देखो, has it decreased in 20 years? True. Correct. ये तो true हो गया. Okay, देखो ना, because this is 2003, this is 2003. The normal वाला people decreased हुआ है. तो true. I want to select the false option. तो C भी true हो गया. Okay, now ratio of the percentage of population falling into underweight to the percentage of population falling into normal weight. Last is the underweight versus. Okay, so you can check it out, right? Of course, let's not repeat the calculation. You know how to deal with it. Okay, done. Let's go to the next question. Okay, ये भी true आ जाएगा. The only incorrect option will be B. It is since MCQ question only as mentioned. Next one. Okay, coming to the next question, number 9. And this is also a decent fundamental question. Okay, geometry. 4 identical cylindrical chalk sticks, each of radius r is 0.5, L is 10, are bound tightly together using a duct tape. Okay, duct tape, that regular brown tape that you use for binding, as shown in the following figure. The width of the duct tape is equal to the length of the chalk stick. Okay, so the length of the chalk stick is mentioned. Length is 10. Okay, that is how much is the width of the duct tape. What is the area of the duct tape required to wrap the bundle of the chalk stick once? Okay, now see, let's look into this picture. Okay, what is the area of the duct tape? Okay, suppose you have already binded it using duct tape. If I open the duct tape, okay, if I just open the duct tape, what will you see? If I open this duct tape, what you are going to feel is ki this is what is going to be one of the dimension. Okay, this is what is going to be one of the dimensions. Suppose this is equal to the L. Okay, and when you unwind it, when you unwrap it, okay, this side, how much is this side? Okay, that is the suppose width. Okay, that is suppose the another base, let's say the base here. Okay, but how much is that base? How much is that base? How much is this equal to? How much is this equal to, dear? Okay, this has to be understood slightly clearly. So for that, let me also take, okay, 4 of these chalks. Let's have a look into the front view, dear. Okay, एक rough figure बनाएंगे. Okay, now when you want to talk about the duct tape, okay, how it is binding it up. देखो, this portion looks straight, but here it is slightly curved. Okay, then again it becomes straight, then it is slightly curved here, then again it is straight. Okay, then here also it is curved, then straight up to here, and then again it takes a curve. Something like that it is. Okay, something like that. Now dear, okay, to obtain this total width, have a look into it. How much is this? Dekho, this is radius which is given to you. Okay, so this much is r, this much is also r. So this straight distance is 2r, and then, okay, how much is this one? What about this curved distance? Okay, now curved, this curve is coming on a circle. What is the circumference or length of a circle? 2 pi r, but how much is this? Is the quarter of a circle. This is the quarter of a circle, so its length should be 2 pi r, or you can also find it by the length of a arc formula, but it is circle, we know the circumference. Okay, 2 pi r by 4. Okay, 2 pi r by 4. Okay, now similarly, how many such straight sections are there? This will be 2r, this will also be 2r, this will also be 2r, and how many such curves are there? 1 on each corner, so there are 4 such curves. So what is the total value of this base? What is the total value of the base? Okay, 2r. Okay, this will also be 4 times, and 2 pi r by 4, this will also be 4 times. Okay, so 2r plus 2 pi r by 4 whole multiplied by 4. Okay, So what is the value of this base? This looks like 8R, and here 4 cancel, plus 2 pi R. Now what is the area of the tape required? The area is, okay, L into B, okay, L into B, that is equal to L. L ka value hai, I think, let me check the value of L once, 10. Okay, 10, okay, into B. Now what is the value of this B? Dekho, isme se what I can do, let's take the 2R common, and then I am left with 4 plus pi, okay, and the value of R is 0.5. Okay, so this is itself 4 plus pi. Okay, so what is this area now? L is 10 multiplied by this 4 plus pi. This is directly 4 plus pi. Correct, na? This one is directly 4 plus pi. I have taken 2R common. Correct. Okay, so 10 into 4 plus pi. Then the answer should be option number D. Then the answer should be the option number D. That's it. Let's move ahead to the next question. Okay. Sequence the following sentences PQRS in a coherent passage. Again, a verbal question, but very easy one. Even if you know to read the statements, you will be able to answer this question. Nothing so great or difficult here. Okay, so एक बार इसको देख लेंगे. Okay, Shifu student exclaimed, "Why do you run since the bull is an illusion?" Shifu said, "Surely my running away from the bull was also an illusion." Shifu once proclaimed that life is an illusion. One day, when a bull gave him chase, Shifu began running for his life. Okay, so once the story starts with Shifu once proclaimed that all life is just an illusion, nothing, everything in the life is illusion. Okay, then what happened one day? Okay, when a bull gave him chase, okay, when bull ran over against him, behind him, Shifu also began to run for the life to save his life. Okay, this is the next event happened. But Shifu once said that all life is illusion. So his student say that, why do you run? Because bull is also illusion. There is no bull. You just feel that it is a bull. Okay, so why do you run? Okay, the student said. Then Shifu replied, okay, surely my running away from the bull is also an illusion. Okay, so the statement should be RSPQ. Option number A. RSPQ. This is the correct sequence. Okay, these are 10 questions of aptitude done, but let's get moving ahead to the mathematics, and as I told you, then we will move towards our technical subjects as well. Okay, now let R and R cube, R3, denote the set of real numbers and the three-dimensional vector space over it respectively. What is the value of alpha for which the set of vectors 1, 2, 3 does not form a basis of R3? Does not form a basis of R3. Okay, for the vectors to form basis of R3, they must be linearly independent. Okay, but here they do not form a basis of R3. That means vectors are linearly dependent. They do not form a basis. The vectors are linearly dependent. Okay, now when the vectors are linearly dependent, the matrix formed, okay, by the columns using these column vectors, suppose the vectors are x1, x2, x3. Okay, the determinant of this vector, because the columns of this vector are dependent, whenever columns or rows of any matrix are dependent, then its determinant should be 0. Its determinant should be 0. Its determinant should be 0. So you just have to check this calculation. The determinant of A, where the first vector is 2, minus 3 and alpha, I have put it into column. You can arrange into rows also, because anyways by taking the transpose operation, you know the determinant is not affected. This is 1, minus 5 and 7. This should be equal to 0. Okay, this should be equal to 0. So solving up, okay, this is 2 into minus 7 plus 15 minus 3 minus 21 plus 5 alpha, okay, and plus 1 into minus 9 plus alpha should be equal to 0. Okay, so this is 16, then this is minus 3 plus 63 minus 15 alpha minus 9 plus alpha equal to 0. Okay, so solve it up. Total on the other side you should have 14 alpha. Okay, and then how much is this equal to? 80 minus 9, this is 71. Some basic error kya calculation mein? Let me check it out once. 2 into minus 7 plus of 15 minus 3 into minus 21 minus plus 5 alpha and plus 1 into minus 9 and minus plus alpha. Okay, this looks okay. then you have 8, 8 2s are 16, and then this is 63, this is minus 14, alpha is 71, 2 and minus 3 and alpha, 3 and minus 1 and 3, 1 and minus 5 and 7. The numbers are also okay. They do not form a basis, I think. No, because alpha should be a perfect value coming at that. That's what I think. Okay, 80 and 80 minus 9, the 71 हो रहा है. Just a second. It's twice 8, 16 minus 3 minus 21 plus 5 alpha and 1 into minus 9 plus alpha. Let me check the exact gate question, dear ones. Do I have it right now? Let me check the exact gate question, because ये perfect answer आ जाएगा. This has to be the perfect answer. Calculations में तो there is no issue that I am able to see. 3 minus 21 and minus 1 is 5 alpha plus 1 into minus 9. So this should be 0. एक बार और tally कर लेते हैं. 60. Oh, I am calling it as 63. I am writing 64. Okay. So this is 70. Yeah. This one is 70. So what is the value of alpha? Here that is 5. What is the value of alpha? That should turn up. It should be the 5. Simple one. Okay, done. Simple one. Let's move ahead to the next one quickly then. The general form of the complementary function of a differential equation. It's a question only based on CF, 1 mark. Okay, is given to you. What is that complementary function given to you? Is AT plus B e raised to the power minus 2t. Okay, now this form comes what? C1 plus C2x. It's of the form C1 plus C2x into e power mx. Okay, this comes, that means m is equal to minus 2 is a real and repeated root of the auxiliary equation. So what should be the auxiliary equation? Okay, minus 2 is a root, so m plus 2 ka whole square. M plus 2 equal to 0 means m is minus 2, because it is repeated to m plus 2 ka whole square. This will help you in forming the differential equation. Okay, so auxiliary equation is m square plus 4m, okay, plus 4a square plus 2ab plus b square equal to 0. Okay, now m usually we replace to solve auxiliary equation, but actually when you bring it back into the derivative form, it should be m square comes for the second derivative. So d2y by dt square plus 4dy by dt plus 4yt should be any function ft. Okay, because we are only finding ft, and for ft anyways, we are only finding cf, and cf ke liye this forcing function anyways is not required. That is considered to be 0. Okay, this is required for finding what? For pi. Okay, so as per the given cf, my answer that is matching is option number A. Simple question. Next one here. Let rho xyzt and u xyzt represent density and velocity respectively at a point xyz and time t. Assume del rho by del t is continuous. Let v be an arbitrary volume in space enclosed by the closed surface, and n be the unit outward normal unit vector of S. Which of the following equation are equivalent to this equation? Which of the options is or are equivalent to this equation? What equation is given? Del rho by del t. Del rho by del t should be equal to, let's send it on the right side, negative of del of rho u. Acha, please mind that it is a MSQ question. From mathematics, normally we expect MSQ question. It is 1 mark because it is just a simple property, a theorem question, I can say. Okay, so now if these two are equal, let's do the volume integral on both the sides. Okay, volume integral of them will also be equal. So one option that is coming up is definitely option number B. Okay. Del rho by del t dv, doing the volume integral on both the sides, minus outside the integral, minus del dot rho u dv. Okay, over some volume v. So definitely B is correct. It is a multiple select question. Maybe one correct, yeah, one or more than one also can be correct. Okay, but now, okay, they are talking about there is some closed surface S and n be the unit outward normal vector of S. ये ध्यान देना यहाँ पे. Okay, and for closed surfaces we apply Gauss divergence theorem. Okay, but that is applied to solve a surface integral. So here we have to think the reverse of Gauss divergence theorem. Okay, Here, if you take the reverse of Gauss divergence theorem says that the surface integral of a vector over a closed surface is equal to volume integral of its divergence. So here you have the volume integral of divergence. Del dot F is a divergence term. Okay, so that can be obtained if you take the surface integral of this vector. So this should be equivalent to surface integral of rho u. Okay, surface integral of rho u. Now how the surface integral is written? Not in the ds vector, n dot ds vector. Okay, surface integral rho u dot n cap ds. Okay, negative sign is there, that will come over the closed surface. So closed surface symbol should also come. Okay, the answer A is also matching up. Answer A is also matching up, correct. Okay, over a closed surface. Gauss divergence theorem se relate ho gaya. It's just a Gauss divergence theorem knowledge question. That is why 1 mark. Okay, MSQ question in mathematics, again 2 mark. Let f1, f2, f3 be the functions of x, y, z. Suppose that for any given pair points of a and b in the space, line integral f1 dx plus f2 dy plus f3 dz evaluates to the same value along any path. Now please see that line integral evaluates to the same value along any path that starts at a and ends at b. Along any path that starts at a ends at b, the line integral evaluates to the same value. Okay, that means line integral evaluates to same along any path. The line integral does not depend on path. Line integral is independent of the path taken. It is independent of the path taken. Correct? Independent of the path taken. And whenever line integral is independent of the path taken, the vector f is conservative. The vector f is conservative and the curl of f is 0. The curl of f is 0. Okay, whenever curl of f is 0, the vector f can also be represented as gradient of some vector. It can also be represented as gradient of some vector. Suppose that vector is f. Okay, that is why option number A will be correct. Okay, because what is the expression for gradient f? Okay, now vector f is f1 dx, f1i plus f2j plus f3k, and gradient is del f by del x. Small f is a scalar function. Del f by del x I cap plus del f by del y j cap plus del f by del z k cap. So this del f by del x will match with f1 and etc. like this. A to definitely correct hai. Okay, no, this is not going to be correct because this is the expression for divergence of the vector. Divergence will not be 0. Now curl is 0. Okay, so everybody knows the formula for curl. You solve by determinant. Okay, when you write down that determinant and put it equal to 0, I hope you can do that. This will come up to be option number C. Curl of f is equal to 0. Okay, for every closed path, the line integral. So when the vector is conservative, the line integral along closed path will be 0. Now, because along closed path, what you can see, line integral along a closed path you can solve using Stokes theorem. What is required in the Stokes theorem? Curl f, but curl f is how much? 0. So the line integral answer will also be 0. Okay, so D is also correct. 2 mark, but fundamental question for 2 mark. Fundamental for 2 mark. Okay. Consider the matrix 1, k, 2, 1, where k is a positive real number. Which of the following vector is or are the eigenvectors of the matrix? Is or are the eigenvectors of the matrix? Dekh lete hain. Okay, which of the following vectors is or are the eigenvectors of this matrix? Okay, now eigenvectors ke liye again MSQ question hai guys. Okay, the third MSQ question in maths. This was also MSQ. Okay. Eigenvectors. Okay, now if x is any eigenvector, okay, let's say this is the matrix A. Okay, let's say x is an eigenvector. Okay, then it should always satisfy ax equal to lambda x. Okay, right. When you take a into x, the answer should be proportional to x, lambda into x. While lambda can be any number, that number is known as the eigenvalue eventually. Okay, so in such questions, what you have to do, you have to just pick up the option and multiply ax. Whenever the answer is proportional to x, that is your correct answer. Okay, so I shall tell you the correct answer here. Suppose if you start with C. Okay, suppose if you start with C. Okay, you try ax. What is the ax? 1, k, 2, 1. That is the A matrix. Multiplied by x, 1 root over 2 by k. Multiply it. Okay, so now first row, first column. So it's going to become how much? 1. Okay, this is 1 into 1. Okay, and then this is k into root over 2 by k. Okay, k into root over 2 by k. So root k will cancel. Here also root k will be left. Okay, so root k into root 2. Root over 2k total. Now second row आ जाएंगे. Second row with this column. So 2 into 1 is 2. 1 into this factor. Now can you take something common here so that you get this similar term? Okay. So that you get this similar term. Can something be done here? देखो. Think about this. Can something be done here? If you want to get this similar term, okay, so what you can do is, this is 1 plus root 2k, okay, and this is यहाँ से अगर 2 कॉमन ले लिया आपने, यहाँ से अगर 2 कॉमन ले लिया तो this is going to be 1 plus 2 has to be multiplied. If you take this entire term common, yeah, that can be taken, and root over 2 by k. ठीक है. So देखो, here let me take from this particular term, इसको मैं अलग से शो कर देता हूँ. We have the term 2 plus root over 2 by k. From here, let us take root over 2 by k common. Okay, then what is left here is 1. Okay, यहाँ तो 1 आया. Plus, now here you have taken root over 2 by k common. So, okay, let me divide also. Justified ना? Okay, when you actually multiply 2 by k cancel, 2 बचेगा. Okay, now what is this equivalent to? This is equivalent to 2 upon root 2. Root 2 आ जाएगा. Okay, and root k denominator का denominator will go to the numerator. So you will be left with this particular term, the first term. Okay, so what I can say is 1 plus root 2k is a factor common to both. 1 plus root 2k if you take outside, okay, then what is left here is 1. Here also if you take 1 plus root 2k outside, then you are left with what? यहाँ पे देखेंगे आप लोग. Then you are left with root over 2 by k. Okay, and this is the given vector. Okay, so this is in the form of lambda x. So definitely C is correct. Okay, little bit arrangement you have to manipulate. Similarly, if you go for the option number D here, AX, what is the A matrix is same 1, K, 2, 1. Correct. And you have 1 and negative of root over 2 by K. Okay, so let's multiply here again. First row 1, then 1 into 1, then minus of, okay, k and root k will cancel. You will be left with root over 2k. Then second row 2 and minus root over 2 by k. Now here once again try to take the term 1 minus root 2k common. If you take it common, यहाँ बचेगा 1. Okay, now let me again explain you once again. 2 minus root over 2 by k में से firstly let me take the minus outside. Okay, firstly let me take the minus outside. So now you have root over 2 by k minus 2, and now let me take the root over 2 by k outside. So now this is 1 minus 2 divide by root over 2 by k, and again this is equal to, okay, 2 by root 2, 1 upon 1 by k, k ऊपर चला जाएगा, तो root k is also above. Okay, and this was 1. Okay, so if you take 1 minus root 2k common, what is left here is, ध्यान देखना, with minus you are left with minus of root over 2 by k. Okay, so ultimately again AX equal to lambda x satisfied. Same x came up here. Okay, so that is also an eigenvector. Option number D is also satisfying the eigenvector. Okay, next one. Let Z be a complex variable. Okay. Let Z be a complex variable. If f of z is equal to sin pi z upon z square z minus 2, f of z is equal to sin pi z upon z square z minus 2, and C is the circle in the complex plane with mod z equal to 3, then what is the value of integral fz dz? What is the value of integral fz dz? Let's see that. It's not a difficult one. We can solve by the residue method. Okay, we are actually interested in integral fz dz. Okay, over the circle C. Okay, over the circle C, and as per the Cauchy residue theorem, it is given by 2 pi I into summation of residues which are inside the closed curve. Only the residues which are inside the closed curve are required, na? Only the residues which are inside the closed curve are required. Okay, now, okay, so this is equal to how much? For that, let's calculate the residues. Okay, now fz. Okay, what are the poles? What are the poles of fz? Okay, what are the poles of fz? वो देखना पड़ेगा. Okay, what are going to be the poles of Fz? Let's see that one by one. Okay, let's take it here. Z square, Z minus 2. Okay, now what are the poles? 0 and 2. These are the two poles. Repetition baad mein dekhenge, but there are the poles 0 and 2. Okay, now what is the given circle? C is the circle with mod z equal to 3 definition. That means radius is 3. Both of the numbers have mod z less than 3. Both of these numbers have mod z less than 3. That means both are inside the circle. Okay, so both residues are to be calculated. I want the residues which are inside the closed curve. Okay, so that means let us come to z equal to 2. Now, when I am going to find the residue of z equal to 2, pay attention. I should write down the fz as sin pi z upon z square whole divided by z minus 2. Please arrange it this way. Please arrange it this way. Okay, yeah, if you want, because it's a simple pole. Now, if you want, you can solve it directly as well. Nothing to worry much about. You can solve it directly as also. Okay, you can solve it directly also. Okay, so z equal to 2 पे जब मैंने residue निकाला, okay, it's a simple pole. The formula for residue for simple pole is limit z tending to a, z minus a, fz. Z minus 2 cancel. Your answer is sin 2 pi. Now z equal to 2. So sin 2 pi divided by 2 square, but sin 2 pi itself is 0. Sin 2 pi itself is 0. Okay, limit z tending to 2 put karenge na. So sin 2 pi is 0. This residue is 0. Okay, now let's come to the next one. Okay, residue for z equal to 0 because we have a z square term in the denominator. What we have is a z square term in the denominator. Okay. Okay, let us write down fz now equal to sin pi z upon z minus 2 divided by z square. Divided by z square. And we express this function as numerator upon z minus a power m. Some numerator upon z minus a power m. And then I say that z equal to a is a pole of order m. And residue for pole of order m is given by nm minus 1a divided by factorial of m minus 1. nm minus 1a. Now what is m minus 1? M minus 1th derivative. It's not the power. M minus 1th derivative here. Okay, so here, okay, the residue will be, let me take one more slide and move ahead. Here, what is going to be my residue? That is going to be nm minus 1 में m का वैल्यू कितना है यहाँ पे? m is equal to 2. Actually z power 2 and a का वैल्यू 0. A is the location of the pole. Okay, a is equal to 0. So residue should be numerator 2 minus 1, that is n1 at 0 divided by factorial 1. Factorial 1 is 1. So n1 0. Now what is the nz? What is the value of the nz? Nz is sin pi z upon z minus 2. Okay, so what is the first derivative of it? This is going to be divided by the z minus 2 ka whole square. Now z minus 2 constant, differentiation of sin pi z will be pi cos pi z minus sin pi z constant, differentiation of z minus 2 will be put 1. Now put the n dash 0. So when I put the value 0, I get this as a minus 2, z की जगह 0 रखा है, into pi into cos pi, z is equal to 0, sorry, into cos 0. So cos 0 is 1. Okay, sin 0 is 0. Okay, divided by 0 minus 2, okay, ka whole square. So this is going to be how much? Minus 2 pi by 4 or minus pi by 2. Okay, so what is the value of the integral? It is 2 pi I into summation of the residues. Okay, what is the first residue? That was 0. And then you have minus of pi by 2. So when you're going to multiply both of them, 2 will get cancelled. Minus pi square I should be the answer. minus pi square I should be the answer. Minus pi square I or minus pi square j, whatever we call it as, minus pi square I or minus pi square j should be the very correct answer. Done it? Okay, so yeah. So, these are the mathematics question, and now time to move ahead towards the digital circuits question. I mean, moving ahead into the technical area, digital signals, control, EMFT, we'll discuss that. So yes guys, now let's get started with the technical subjects, starting with digital circuits first of all and moving to the next then. Okay, so this question is the first simple question, and it is actually, you can call it from COA. Okay, the basic computer organization and architecture, but a very logical one. Even if you have the basic idea about even the simplest microprocessor like 8085, you should be able to answer it logically. Okay, a machine has a 32-bit architecture with a one-word long instruction. Okay, so now it has 24 registers and supports an instruction set of size 40. Okay, each instruction has 5 fields. Okay, namely opcode, 2 source registers. Okay, 1 destination register. Okay, and an immediate value, assuming that immediate value is unsigned integer, what can be its maximum value? Okay, now if you talk about instruction, it has opcode. Okay, it has 2 source register. Okay, it has 2 source register, RS1, RS2. It has a destination register, suppose RD, and it has some immediate value. Okay, these are the 5 fields. Okay, these are the 5 fields. Now it has an instruction set of size 40. It has an instruction, matlab the total number of instructions are 40, and every instruction is identified by opcode, operational code, which tells what the instruction will do. Okay, so to design 40 different instructions, how many bits of opcode is required? Okay, how many bits of opcode is required? That should be 6 bits. Why? Because using 5 bits, you can form 32 combinations. So you can form 32 instructions maximum. To form more than 32 instructions, okay, any number more than 32, you need 6 bits minimum. Okay, now there are 24 registers, and this is a source register, again a register, again a register. Okay, so forget whether it is source or destination. To identify 24 register, every register is also coded in binary in any architecture. Okay, suppose there are 4 registers in any architecture, so they will be coded as 0001, 1011. Okay, there are 8 registers, so they will be coded as 000001, etc. Okay, but now there are 24 registers. So how many bits will be sufficient to identify the 24 register? Okay, 5 bits now, because 4 bits also can help you solve up to 16 combinations. So for any register 5 bits are required. For any register 5 bits are required. Okay, and then comes the immediate value. Okay, so how many can be the number of bits for this immediate value? We know that 6 plus 5 plus 5 plus 5 is the total size of the instruction. And how long is the instruction? 1 word. What is the size of the word? That depends on the architecture. It's a 32-bit architecture, so 1 word here is 32 bits. Okay, so this should be total 32. Okay, so the value of n, this is 15 and 21, n is 11. Okay, so the immediate value can be of 11 bits. The immediate value can be of 11 bits. Okay, now if it is an unsigned integer, what is the maximum value? Okay, in 11 bits, what is the maximum possible value? Okay, it is 2 power 11 minus 1, that is 2048 minus 1, 2047. Okay, why? What is the maximum 3-bit number? 2 power 3 minus 1, that is 7. What is the maximum 4-bit number? 2 ki power 4 minus 1, that is 15. Similarly, what is the highest 11-bit number? 2 ki power 11 minus 1, that is 2047. Okay, that's what it is. So it's a logical question, that's what I meant here. Number 1, the 18th question on number system here. In a number system of base r, okay, what is the base r? That is not given. The equation x square minus 12x plus 37 has x equal to 8 as one of the solution. X equal to 8 is one of the solution. That means it should satisfy the equation. It should satisfy the equation. 8 square minus 12 into 8 plus 37 equal to 0, and everything is in base r. Now please don't start writing 8 square is 64. If you start writing and if you start calculating as decimal, you will never match the answer. Why? Because this is not decimal, it is some base r. Okay, now what is the value of the base r? Let's convert it to decimal. Okay, let's convert this to decimal and then you shall be able to understand. Okay, if you convert to decimal, 8 remains to be 8, so that's going to be 8 then into 8. Okay, Now 8 is one of the solution. Definitely the value of the r is greater than the value of the digits that is coming up. Okay, 1 2 3 7 8 इससे बड़ा होना चाहिए. Now what is 12? Okay, 12 1 into r plus 2, conversion of base r to decimal. Okay, again multiplied by 8. Now what is 37 in base r? 37 to decimal, so 3 into r power 1 plus 7, 3r plus 7. This should be total equal to 0. This should be the total equal to 0. Okay, now 8 8 is 64 in decimal minus r plus 2 into 8, so then 8r plus 16. अच्छा bracket open ही कर देते हैं, तो you'll have minus 16. Okay, plus 3r plus 7 should be 0. So this is like 5r. So this becomes 48. 48 plus 7, 55. So r should be 11. Okay, if x is equal to 8 is one of the solution given. Okay, converting it to decimal. Okay, 0 will remain 0 in decimal. Okay, so that means the value of the base that is matching is r equal to 11. R equal to 11. Let's move ahead to the next one, number 19. For the Boolean function f, a, b, c, d, summation m, etc., 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 what are the essential prime implicants? Okay, so the best way of finding the essential prime implicant is again through K-maps. It will be a simple one only. Okay, so if I take the K-map to solve this process again, 4 variable K-map has to be considered here. So let's consider that. Okay, now, okay, the variables are A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0. At these two, A is high. At center 2, B is high. This is how I allocate the region. Again, gray code here, 0, 0, 0, 1, 1, 1, 1, 0. Okay, this is C, high is high. And in the center 2, D is high. Okay, this I call it as D. Now, let me fill the minterms. The minterms are 0. Okay, then 1, 2. 5, 6, 7, then you have 8, 10, then 11 is not here, 12, 13, 14, 15. Now to find the essential prime implicants, or first the prime implicants, let us form all the possible pairs or quads, whatever you can form. Okay, definitely all possible, whether they are going to come up in the reduced answer or not, minimized answer or not, that you don't have to worry. I'm not solving a expression, minimized expression of a function using K-map. If while finding the prime implicant, you have to find all possible groups, provided it should be largest group. I mean, if you are able to form a quad, you should never take a pair out of it. Okay. Now this is one quad. Definitely there is another quad here, another quad here. Then these 4 corner ones are also adjacent, so they also make a quad here. Okay. Now you might be seeing that all minterms are exhausted, but still I'm telling you to find out all possible groups that you can find. So these 2 ones and these 2 ones also make a quad. Okay, that is also one more possibility I'm going to consider. These 2 also make a quad, so I have considered that also as the quad. Okay, so you have to think in that direction. It's like a puzzle problem for prime implicants. Okay, now what are these quads? These are the corner ones. It will be B bar, D bar. Now this particular quad that I have just taken, these 2 ones and these 2 ones, this is clearly within A and outside of D, so A, D bar. Okay, then this is the third row, which is in A as well as B both. It is fitted in AB. What else is left? The center one. So you can see that this is in B as well as in D. So it is BD. Okay, what are the prime implicants? Okay, all these pairs, okay, or groups like AD bar, AB, BD, B bar, D bar. Sometimes they ask only the prime implicants. So this would be the answer. But the question is essential prime implicants. Okay. Now what are the essential prime implicants? वो देख लेते हैं. Now in finding the essential prime implicants, what you will do is you will highlight those minterms which are covered under a single group. Okay, like this minterm, it is covered under a single group only. That is B bar, D bar. This is same only. So if you want, let me write it here. Here are B bar, D bar. Okay, these 2 are minterms which are covered under a single group. Okay, if a particular minterm is covered under a single group, highlight that minterm and its particular group is going to become essential. This is also alone, but it is under the same group, so no need to highlight that. Now let's come here. This is also a minterm which is covered under a single group. Okay, so its particular group becomes essential. This is necessary to carry forward, otherwise this minterm is missed. Similarly, this minterm is also alone, but in the same group. So I will not highlight that. Now come to this, dear. Is this minterm alone? It is covered under this horizontal row also. It is covered under ye wala quad also. So this is not to be highlighted. This is not to be highlighted. Similarly, this is also under multiple groups, multiple groups, multiple groups, multiple groups, multiple groups. So whenever a minterm is under multiple groups, don't highlight. Only find those minterms which are under a single group, and then those groups are essential. So what are the EPIs then? Those prime implicants are essential. Okay, zaruri ho jate hain unko lena, because without them, those single minterms will be missing. The essential prime implicants is BD and B bar D bar. It's an important topic. You can watch my complete videos also on this topic. It's available on the YouTube. Prime implicants and essential prime implicants, right? Okay, next question. The propagation delay, a basic question on delay. So previously 1 mark, now it's coming to the 2 mark question. Okay, the propagation delay of 2 cross 1 mux shown in the circuit is 10 nanoseconds, and consider the propagation delay of the inverter as 0 nanosecond. If S is set to 1, then what is the output Y? If S is set to 1, that is a select line, okay, is equal to 1. Whenever select line is equal to 1, the output is connected with I1. Okay, the I1 is transferred to the output. And what is I1? Now, if this is Y, okay, if this is Y, the same Y comes here. So this is the complement of Y. So output will be complement of each other. So because the previous output is used, let me call it as the next value of the output. Okay, so because the select line is always 1, Y plus equal to Y bar. Okay, now consider the delay of the mux as 10 nanoseconds and the delay of inverter is 0. There is no delay here, but there is a delay of the mux which is 10 nanoseconds. Okay, if it's set to 1, then what is the output? Now maybe Y, what is the initial value of Y? I don't know. So we can assume let Y equal to 0 initially. Let us start that the device is initially reset. So it is 0. Okay, but again, after some time, after how much time? Okay, if it was 0, this 0 comes here, this 1 comes up here. Okay, and then this 1 is going to travel to the output, but that will take a time of 10 nanoseconds. So after every 10 nanoseconds, inversion is going to happen. After every 10 nanoseconds, inversion is going to happen. Okay, it becomes 1. Then again it becomes 0 after 10 nanoseconds. Again it becomes 1 after 10 nanoseconds. Again it becomes 0 after 10 nanoseconds. And that is why a periodic waveform is obtained in front of you. Okay, how much is this time gap? Okay, for every switching or toggle, it needs 10 nanoseconds. Okay, now what is the total time period then? This is the repetition. Okay, this is the time for toggle, 10 nanoseconds. After every 10 nanoseconds, toggle is happening. Okay, then what is the total time period of the waveform? It is actually 20 nanoseconds. It's a square waveform having the time period of 20 nanoseconds. So frequency would be how much? Okay, shift the 10 power 9 to the numerator, that becomes 10 power 3 and 10 power 6. Okay, divide by 20, 1000 by 20, if you cancel, that's going to be 50. 10 power 6 is mega. Okay, so it is a waveform of 50 megahertz frequency, and hence we have the answer as A. A square waveform of frequency 50 megahertz. Okay. So these were the 4 options, out of which A is correct. Let's move ahead to the next one, number 21. A 4-bit priority encoder, it's also a decent question, has the inputs D3, D2, D1, D0 in the descending order of priority. Okay, in the descending order of priority. Okay, so this is the descending order of priority. D3 has the highest priority, I can say. Okay. Now the 2-bit outputs is generated as 0001, 1011 corresponding to D3, D2, D1, D0. Now normally, for D3, D2, D1, D0, we have 111001 and 00. D3 ke liye 11. Okay, D0 ke liye 00. But here they have coded as separately. No problem. We'll form the truth table as they say. What is the Boolean expression for the output bit B? Okay, so dear, have a look into it, dear. Okay, so the inputs here are D3, D2, D1 and D0, and the output bits are AB. If you form the truth table, the problem is going to become very easy for you. Now D3 has the highest priority. That means whenever D3 is 1, okay, whatever may be the other inputs, will I care about their state? Whether they are 0 or 1, don't worry. The output should be according to D3, and for D3 it should be 0, 0. Okay, the output is 0, 0. Right. Similarly, now if D3 is 0, then I will think about next. So next D2, D2 1, and D2 is higher than D1, D0. So now I don't care about D1, D0. Okay, but if D2 is high, of course D3 is 0, then the output is according to D2, which is 0, 1. Okay, which is 0, 1. Now similarly, D3, D2 both 0. So next hum chance denge D1 ka. If D1 high, then I don't care about D0. Output should be 1, 0. And similarly, last 0, 0, 0, 1. If D0 is high, all the other higher priority inputs are low, then the output should be according to D0, which is mentioned as 1, 1. Okay, but there is one case which is normally not mentioned. You have to consider it here, and that is, okay, when all the inputs are low. And if it is not mentioned here, now sometimes they can mention, okay, but when all the inputs are 0, then because the output is not mentioned, so we can consider it as don't care. We can consider this as don't care variable. Okay, now what is the expression for the output bit B? What is the expression for the output bit B? Chalo solve kar lenge. What is the expression for the output bit B? Okay, as seen from this truth table. You can find for A also, ठीक है, but yeah, let us do it for E. Let us do it for B. पहले जिसका पूछा है उसको कर लेते हैं. Now see, B is high at 0, 1, XX. Now what is the meaning of XX? I told you, I don't care about D1, D0. That means they can be in any state. So for these two unknowns, there can be 4 states, 0, 0, 0, 1, 1, 0 and 1, 1. So 0, 1, D3, D2, 0, 1 hona chahiye. Yeah, if you want, I can write down the supporting gray codes also here. This is 0, 0, 0, 1, 1, 1, 1, 0, so that it is easy to see. 0, 0, 0, 1, 1, 1 and 1, 0. Now what I am telling, D3, D2 should be, okay, for B high, D3, D2 should be 0, 1 state. Here are 0, 1 and D1, D0 can be in any of the 4 states. Okay, so that means here B is high. The next condition, B is high at the last 0, 0, 0, 1, 0, 0, 0, 1 and at 0, 0, 0, 0 don't care aayega. Okay, so definitely there are two quads, okay, that is going to be formed. There are these two quads. Okay, one is the second row, and to group this one, if you use the don't care is always in your hand in K-map. You can use it as 1 or 0. If it is helping in minimization, use 1. So yes, if I use 1, I am getting a quad. Okay, so what is this? This is D3 bar and this is D2. Above D3 and within D2. What about this one? Okay, this is D3 bar above D3 and outside D1, D1 bar. Okay, so the expression for B is going to be D3 bar, D1 bar plus D3 bar, D2. Okay, D3 bar, D1 bar plus D3 bar, D2. It is C. Correct. It is the option number C. Similarly, you can find the expression for A also. That you can do it as homework. Okay, same way, you have to just feed this into the K-map and find the expression for A. वो भी simply आ जाएगा. Let's move ahead to the next question. A basic SNR question from the ADC. Okay, so a full-scale sinusoidal signal is applied, okay, to a 10-bit ADC. The fundamental signal components in the ADC has the normalized power of 1 watt and the total noise and distortion normalized power is 10 microwatt. What is the effective number of bits? Dekho, when you talk about the SNR calculation, okay, you can compare it with two formulas, signal to noise ratio. Okay, so the fundamental signal component is given to you as 1 watt. Upon the noise normalized power is 10 microwatt. Okay, so here I get this ratio 10 microwatt, 10 into 10 power minus 6 and in decibel. अच्छा पहले इसको decibel में convert कर लेंगे. So this is 10 power minus 5 going above 10 power 5. When you want to convert in dB, because we have another formula for SNR that is in the decibel, but let's first find this in dB, and because it is the power term, so 10 log, we take 10 log of this term, 10 log 10 power 5, log 10 will be 1, this is going to 5 outside, 5 tens are 50, this is 50 dB, this is going to be 50 dB. Okay, now also the SNR, which is 50, should be given by what formula? 1.76 plus 6.02 n. Okay, so let us solve the value of n from here. How much it is going to be? divided by 6.02, so 8.013. Okay, rounding off to nearest integer, clear bola hai. Okay, so it is 8. The answer, rounding off to nearest integer, it is option number A, that is 8. Done hai ji? Okay. Next question, 23. The sequence of the states Q1, Q0 of the synchronous sequential circuit, a regular question, expected question as always from counting of the states, a counter based question. So let's do it. Okay, normally we start with 0, 0, so we can start with 0, 0. Okay, let us start again by assuming Q1, Q0 is initially reset. If it doesn't work up, sometimes 0, 0 is a lockout state also. But yeah, let's try with 0, 0 only. The first thing is 0, 0. Okay, so this is 0, this is 0. Now, what T flip-flop we know, if for T flip-flop, if the input is 0, the output will not change. But if the input is 1, output will toggle. T is for toggle. So right now, what is the state? देखो ये 0 यहाँ पे आया, तो this input is 0. Okay, and then the 0 comes here, and this is derived from Q0 bar. So Q0 bar will be 1. This 1 comes up here, or get any input 1, output is 1. So now look into the both the inputs. Okay, one input, so Q1 to toggle hoga, but T0 input is 0, so Q0 will not toggle. So next state should be 1, 0. Next state should be 1, 0. Now everything refresh. Now the state is 1, 0. So this toggle will be 1. ये यहाँ पे आ गया, this 1 also comes up here, so T1 is still 1. Now this is 1, this is 0, but no problem. Now OR gate input 1, output will be 1. Now both the T inputs are 1, 1. That means both the flip-flops should toggle. So this should become 0, this should become 1. Now everything, let me refresh, write down the updated value. Okay, so this is 0, this is 1. Okay, now this 1 comes here. Okay, so 1 plus 0 will be 0. If Q0 is 1, its toggle is 0. Okay, and yahan se aaya Q1, this is also 0. Now here T1 input is 0, so Q1 will not change. Okay, but T0 input, this is 1 na? Okay, so this will also be 1. ये मैंने 0 लिख दिया था by mistake. Okay, if T0 input is 1, so Q0 will toggle. It was 1, now it becomes 0. And if it toggles, the state repeats. The state repeats. So what is the counting sequence? Okay, 0, 0, 1, 0, 0, 1. Okay, 0, 0, 1, देखो 0, 0, 0, 1 भी नहीं है, ये भी wrong है. 0, 0, 1, 0, 1, 1 नहीं आएगा. 0, 0, 1, 0, 0, 1. So it is not necessary that options start with 0, 0. Don't, be misguided कि A या B ही होगा. Okay, 0, 0 can be written anywhere ना? Okay, तो हमें ये देखना है कि 0, 0 के बाद, okay, 0, 0 के बाद 1, 0 होना चाहिए. 0, 0 के बाद 1, 0. Then, after 1, 0, I have 0, 1. Perfect. After 0, 1, back to 0, 0. Perfect. Yeah, option number D. Got it? Option number D. They have started the sequence with 1, 1. No problem. No problem. If you start, you can start with 1, 1. अच्छा देखो 1, 1 से start तो कर दिया है, चलो 1, 1 is not in the regular count. It is actually unused state. But if I show you 1, 1 calculation also, देखो 1, 1 will now be an unused state. Okay, but suppose if I take both the outputs as 1, 1, let me explain you that also. This is 1, this is 1. Okay, so toggle will be 0. This comes 0, but यहाँ पे आया 1. This input is 1, 1. Both the T inputs are 1, 1. Dear, if both the T inputs are 1, 1. Okay, then both the outputs will toggle. Okay, and ultimately you jump here and then you recycle through a regular state. Normally, what is this state known as? Normally, we call this state as, okay, unused state. It comes only as a startup effect, but it is never going to repeat. And the machine is self-starting. Ki by chance, if the machine goes into 1, 1, it will automatically return back to the one of the regular state. Okay, anyways, our answer is matched. That is option number D. Let's move ahead to the next question. Okay, now we have control system as well. Very simple one. In the context of Bode magnitude plot, 40 dB per decade is same as 20 dB per decade is 6 dB per octave. 40 dB per decade is 12 dB per octave. Option number B. It is simple one. Chalo, let's move ahead to the next. In the feedback control system, one more question only shown in the figure. I doubt whether it was MCQ or MSQ. I think this question was MSQ, but I shall check it up once. Okay, I will check it up once. Okay, I'll check it up after some time. Don't worry. Okay, but I get the feeling that this was MSQ. Okay, but no problem. Okay, ultimately I'll tell you how many options are correct. But as far as I remember, shayad MSQ tha. But theek hai, I will confirm it. So in the feedback control system shown in the figure, GS is 6 upon S, S plus 1, S plus 2. RS, YS, ES are the Laplace transform of RT, YT and ET respectively. If the input RT is a unit step function, then what? Okay, RT is a unit step function. Then what is the condition of limit t tending to infinity ET? Okay, steady state error, steady state error, steady state error. Now the catch in the question is ki if you just write down the characteristic equation once, if you write down the characteristic equation 1 plus GSHS equal to 0, so 1 plus 6 upon S, S plus 1, S plus 2 equal to 0. So solving it, I have S cube 1 plus 2 3S square, then plus 2S plus 6 equal to 0, and then you will see that because it's a cubic equation, I can apply the shortcut. Okay, 1 into 6 is 3 into 2. Whenever inner product equal to outer product, the system is marginally stable. Okay, or you can solve using Routh as well. Okay, that's a shortcut coming up from Routh, especially for cubic equation. So inner product is outer product, so the system is marginally stable. Okay, and if the system is marginally stable, output is oscillatory, and as well as the error is oscillatory. Output को क्या बोला यहाँ पे? YT is oscillatory. It will never settle to a value. It will not be unbounded also. Okay, and if the output is oscillatory, the error is also oscillatory, and hence there cannot be any fixed value of the steady state error. Answer is A. Only one option will be correct undoubtedly. Okay, so but thoda sa se yaad aa raha hai, maybe because in MSQ also one option may be correct. I'm not sure. I will check it out. But anyways, we have solved the question. It should be A. Okay, it should be the A. Okay, decent question for 1 mark. Next one, okay, a 2-mark control system question. Consider a unity negative feedback control system with the forward path gain k upon s plus 1, s plus 2, s plus 3 as shown. The impulse response of the closed loop system decays faster than e की power minus t. Now this is a good one. It's a good language, I mean. Okay, the impulse response of the closed loop system decays faster than e की power minus t if what? The impulse response of the closed loop system decays faster than e की power minus t if what happens? Now we know that the terms which are closer to the origin decay slowly, the terms which are far and far away from the origin decays faster. Okay, the terms, okay, or the poles, the terms closer to origin decay slowly, they are more dominant. Dominant pole concept में हम study भी करते हैं. Decay slowly, so they stay for more period of time, so we have to look into their analysis. Decay slowly as compared to the terms, okay, that are far away from origin. Everything in LHP, because if a term is in RHP, then it does not decay, it actually exponentially grows. Okay, so for the term e power minus t, देखो, for the term e power minus t, what is the Laplace transform? We all know 1 upon s plus 1. Okay, so what is the pole for 1 upon s plus 1, dear? The pole is s equal to minus 1. For the 1 upon s plus 1, the pole is s equal to minus 1. Okay, now, okay, if you want the impulse response decaying faster than this e power minus t, faster kab hoga? When you are away. Okay, now you want faster than e power minus t. Okay, that means poles should be, okay, poles should be away, that is left off, more left off. Okay, the pole s equal to minus 1. The poles should be left off s equal to minus 1. Okay, the poles should be left off s equal to minus 1. Okay, question is like this. What is k? Okay, I'll draw a picture also here. Let me explain it to you. So we do have a pole, okay, which is at minus 1, and all the poles should be left of this, anywhere but left of this. Okay, so now I take a straight line passing through minus 1, which is parallel to the y-axis, and that straight line has the equation sigma equal to minus 1. Okay, sigma equal to minus 1, just like x equal to constant, a line parallel to y-axis. What is k? Okay, for poles to lie left of the line, sigma equal to minus 1. Okay, normally we study this as the concept known as shifting the origin, relative stability under the Routh-Hurwitz. Okay, so now, okay, what is the value of k for the poles to lie left than sigma equal to minus a? What you do is, to solve it, you replace s okay, by s minus 1, okay, by s minus a, okay, in the characteristic equation. In the characteristic equation. But what is the actual characteristic equation, dear? Okay, what is the actual characteristic equation? तो पहले characteristic equation लिखेंगे. Okay, what is the old characteristic equation? 1 plus GSHS, that is 1 plus K, okay, upon S plus 1, okay, S plus 2, S plus 1, S plus 2, S plus 3 equal to 0. Now you can solve and form a cubic equation. Yeah, then you can replace S by S minus 1, or here only you can replace S by S minus 1 so that it is easy to solve. यहीं पर replace कर देंगे. So your newer equation is going to become S is replaced by S minus 1. So S minus 1 plus 1, only S. S minus 1 plus 2, S plus 1. S minus 1 plus 3, S plus 2. So it is simple to solve if you substitute here and then form the complete cubic equation. S cube, okay, plus 3s square plus 2s plus k equal to 0. Now when you replace s by s minus 1, what is the idea? Why do we do replacing s by s minus 1? Okay, that means we are shifting the poles 1 unit right. Okay, so normally what should be done is we want to shift the origin, we want to shift the y-axis 1 unit left, because if we apply Rao-Hurwitz can always tell you that with respect to the y-axis, with respect to the boundary, whether the poles are left and right, left or right. But I want with respect to this line. So the idea is shift this imaginary axis. But rather than shifting the origin, I do reverse, shift the poles to the right. Okay. So now because you have shifted poles to the right, you can say that now this is the y-axis. Now how many of them are to the left? Okay, how many of them are to the left? That means you want all of them to the left. All of them to the left. That is why the impulse response will decay faster than e power minus t. You want all the poles lying to the left of sigma equal to minus 1. Sigma equal to minus 1. Okay, and that can only come, okay, that can only come, left poles can only come, okay. Marginally stable condition is inner product equal to outer product. Left poles will come when 3 into 2 is greater than, inner is greater than the outer. Okay, so what you want is in that case, k should be less than 6. Okay, 6 greater than k, या k less than 6. Okay, left, यहाँ पे left का मतलब क्या है? Left here is not left half plane but left of sigma equal to minus 1 because of the changes we do. Again, you can study this particular topic under the Rao-Hurwitz in our previous videos. Okay, so k should be actually less than 6. Okay, so now there is no option directly containing k less than 6, but what is the option that will match here for k less than 6? It is option number A. Okay, of course k is positive here. Okay, so generally we write down the answer as 0 less than k less than 6. So the 1 to 5 is a subset of it. So only A option will match up here. Only the A option will match up here. Done, G? Done, G? Okay, the A option will definitely is going to match up here. The A option is definitely going to be the matching up here. Okay, just a second. Yeah, okay, so let's get moving ahead and let's get started then. Okay, let us continue with the next question. Okay, so what is the next question we have is, yeah, so a state space analysis question, which is always an expected topic for ECE. Consider a system, okay, S represented in the state space as dx by dt equal to 0 minus 2 1 minus 3x plus 1 0 r with y equal to 2 minus 5x. Which of the state space representation given below have the same transfer function? MSQ question is here. Have or has the same transfer function as that of this system X. Okay, and now this is not in the any of the CCF or OCF form. Okay, it is not in the CCF or OCF form. Okay, so we need to solve it normally. Yeah, it's not CCF, it's not OCF also, otherwise this should be 0 BU. No. Okay, so let's solve this. Okay, how do we find the transfer function of this system? Okay, this is some matrix A, this is some matrix B, this is some matrix C. Okay, so we have dx by dt, that is x dot, the derivative ax plus bu, yeah, br, r is the input here, and y equal to cx. The transfer function, okay, is given by the formula c phi s into b, okay, plus d. Okay, plus d. Okay, where the y is cix plus dr, that is a general equation. Okay, so what is the value of d? That is not mentioned here. That means it is definitely 0. And what is the value of phi s? What is phi s? It is the Laplace transform of state transition matrix, and it is given by the formula Si minus a whole inverse. C and B are given. We will multiply later, but first we have to find the phi s. Si minus a whole inverse, where A matrix is given to me. Okay, then we can see this transfer function matches with which options. Okay, so let us start with this calculation that is known as the Si minus A. Okay, Si minus A. This is the identity matrix minus the A matrix. Inverse baad mein likha lenge. Let me calculate Si minus A matrix. This is 0 minus 2 and then 1 and minus 3. 0 minus 2 and then 1 and minus 3. Clear? Okay, now, yeah, here it is. So what is this Si minus A? So I have multiply karenge, so I get s minus 0, that is s, then this is 0 minus minus 2 plus 2, then 0 minus 1, and then s minus minus 3, s plus 3. Okay, this is the Si minus A. Now how do I form the inverse of this matrix? Si minus A whole inverse. Inverse of a matrix is given by the formula adjoint divided by determinant. Adjoint of Si minus A divided by determinant of Si minus A. 2 cross 2 adjoint is always a simple calculation. Why? Okay, because you just have to exchange the diagonal numbers s plus 3 and s, and you have to just change the sign of the off diagonal numbers, so minus 2 and plus 1 divided by determinant of Si minus A. So determinant, simple cross multiplication, s plus 3 minus plus 2. Okay, that is the Si minus A whole inverse. Okay, now I want to calculate C phi b. Okay, let us start with the transfer function, and that is the calculation C phi b. D term is 0. Now let me write down the C term, 2 and minus 5. That is the C matrix into phi matrix. Okay, that is s plus 3 minus of 2 plus 1 s divided by s square plus 3s plus 2 into the B matrix. What is the B matrix? Is 1 0. Now what to multiply dear first? This is a scalar term that we can write outside also. C into phi or phi into B. You can multiply any of them, but look into the numbers. Decide according to the numbers. So here I will first multiply phi b, because multiplying something with 0 will cancel out that term. So initially you will get smaller terms. Then we'll go to the next multiplication. So I'll write down C as it is, 2 and minus 5. And now I'm multiplying this phi with B. So s plus 3 into 1, s plus 3 minus 2 into 0, 0. That is why it becomes simple. Now second row pe aa jayenge, 1 into 1, s into 0. So only 1 into 1, that is 1. So that is how it becomes simple. Whole divided by that term s square plus 3s plus 2. Now 2, this is looking like 2 into s plus 3. Okay, first row, first column, and minus of 5 upon s square plus 3s plus 2. So what is that transfer function, dear? My transfer function is turning out to be 2s plus 6 minus 5. So 2s plus 1 upon s square plus 3s plus 2. Now it is a time taking question, no doubt, because now you have to match, okay, the transfer function of all the options and what is the correct option matching up. Okay, now for the option number A or C, it is going to be simple because it is in the DCF form. Okay, option number A or C are going to be simple, they are in the DCF form. Okay, so for option number A or C, okay, these two are in the DCF form, diagonal canonical form. Okay, and 0 1 minus a0 minus a1 plus 0 bu y equal to c0 c1 x. Okay, ये 1 0 रिवर्स कर दिया है, d के लिए अगेन सॉल्व करना पड़ेगा. I think this was given to as 1 0 या 0 1, वो चेक कर लेंगे. Okay, that we will check it out. Okay, just don't worry about that. Okay, so now out of the A or C, DCF में transfer function लिखना is very simple, because for A, if I want to write down the transfer function ना, okay, it is given by, okay, एक टर्म आएगा s plus 1 का corresponding to this pole. Guys, how do we write it? This is a shortcut I'm following, so you can watch the videos on the DCF, the state space model. Now the first term is 1 and 1 here, so this is 1 into 1. The second to second term product 1 into 2 corresponding to the second pole, which is minus 2. Okay, so this is given by 1 upon s plus 1 plus 2 upon s plus 2. Now when you solve, s plus 2 plus twice of s plus 1, so s plus 2s 3s. Okay, plus 2 and plus 2 plus 4 upon s square plus 3s plus 2. But I want 3s plus 1. I want 3s plus 1. So A is not correct. A is not correct. Now for C, dear, for C के लिए क्या होगा? Okay, minus 1 into 1 upon s plus 1. Now second to second term 3 into 1 divided by s plus 2. Okay, let me simplify this. So minus s minus 2 plus 3s. 3s minus s आ जाएगा 2s. I want 2s only. Perfect. Okay, this is minus 2 and plus 3. Plus 3 and minus 2. So yes, plus 1 is left upon s square plus 3s plus 2. Okay, so definitely C is matching up with our calculation. C is correct. Okay, C is correct. Okay, then let's come to the option number B. Okay, let us come to the option number B. 0, 1, minus 2, minus 3. Now this is, option number B is a CCF form. Okay, CCF form. So I can write down the transfer function directly. Okay, this is also 0, 1. This is also 0, 1. This is also in CCF form. Okay, this is also going to be 0, 1. Okay, so these two are CCF model. So what is the transfer function for the option number B? Let me write down directly. Okay, this is B, which is 1. Okay, this is C1, C0, C1, and denominator तो simple है. This is the constant term with opposite sign. Then plus 3s plus s square. Okay, ये तो match हो रहा है. Okay, now C0, C1. C0 is the constant term. C1 is the coefficient of s. So it has to be 2s then. So 2s plus 1 upon s square plus 3s plus 2. तो B तो match हो रहा है. Okay, but if you take option number C then. Okay, C में देखो B का value 1 है. Okay, C0 is 0. Okay, so it is going to be only 2s plus 0 upon s square plus 3s plus 2. Okay, so this does not match. B will match. The correct answer is B and C. For this MSQ question, the correct answer is option number B and option number C. Okay, option number B and option number C. Okay, now the only thing is, if we did not know these shortcuts, then this question will become extreme lengthy for you. Okay, because this is the general way of solving the transfer function. You first solve for the question, then you solve for all the options. So that's definitely time consuming. Na? That's definitely time consuming. Okay, so these techniques, what is the OCF form, CCF form, DCF form, JCF form, must be known to all of you. Now coming to the next question, that is number 28. Okay, a satellite altitude control system होना चाहिए, as shown below, has a plant with the transfer function gs1 upon s square cascaded with the compensator k s plus alpha upon s plus 4, where k and alpha are positive real constants. In order for the closed loop system to have poles at -1 plus minus j root 3, what is the value of alpha? Okay, again the poles lying at, okay, I'll tell you a shortcut for this. Okay, but this says that, okay, poles lying, okay, on the line sigma equal to -1 plus minus j root 3. Okay, both the poles are lying at sigma equal to -1. Again, let me take, okay, this system, and the real part of the poles is -1. Okay, -1 plus j root 3, -1 minus j root 3, because both have the part, real part -1. So that means sigma equal to -1 will satisfy both. Both the poles lie at sigma equal to -1. So again that same method, replace s by s minus 1. Okay, again that same method as I told you, method number 1. Okay, replace s by s minus a, s minus 1 in the characteristic equation, and then solve. Because when you replace s by s minus 1, it will be equivalent to a picture such that you have shifted the origin. Now what is the condition that the poles lie on the imaginary axis? Marginally stable system. Okay, but what is the method number 2 here? यहाँ पे इसको थोड़ा सा हम simple करेंगे. How can I make it simple? Okay, GATE, graduate aptitude test in engineering. So we can solve it by a regular aptitude approach. First of all, what is the characteristic equation? The characteristic equation is 1 plus, these two are cascaded. Okay, so the gains are multiplied, k s plus alpha divided by s plus 4 is multiplied by 1 by s square. Okay, right, and that is equal to 0. So solving it, I get s square into s cube, then I have 4s square. Okay, then I have ks, then I have k alpha equal to 0. Correct hai? S cube plus 4s square plus ks plus k alpha. Okay, replace s by s minus 1. That is the first method. Okay, that is the first method. Now method number 2. Method number 2. You are directly given poles. Poles are the roots of characteristic equation, dear. What are these poles? These are nothing but roots of characteristic equation, and root should be minus 1 plus j root 3. Okay. Satisfy minus 1 plus j root 3 or minus 1 minus j root 3. जो मर्जी आए, कोई एक satisfy कर दीजिए. You can satisfy anyone, na, actually. You can satisfy anyone. So minus 1 plus j root 3 whole cube. Okay, this is going to be just a basic calculation then. Whole square plus k into minus 1 plus j root 3. Okay, plus k alpha equal to 0. Okay, equal to the 0. So let's start solving these numbers. Okay, let us start solving these numbers, and let's make the calculation also little bit more simple at the beginning level only. ठीक है, तो चलो अप्लाई करते जाते हैं. So if I take this cube, this is 1 minus 1 का cube, sorry, minus 1, then j root 3 का cube. Yeah, this is what I can directly do, I think, in order to have the poles at minus 1 plus minus j root 3, and I'm getting a cubic equation. Yeah, just you have to go forward and start calculating the numbers. ठीक है, इसको थोड़ा सा simple करना है, तो let me take the minus 1 plus j root 3. Okay, totally common to make the calculation simple. Then this is square, and then this is minus 1 ka square 1. Okay, j root 3 ka square will be minus 3. Okay, and then minus 2ab, so minus 2j root 3. Okay, minus 2j root 3, minus 1 plus j root 3 outside, so now 4 multiplied to minus 4 and plus 4j, 4j root 3, minus 1 plus j root 3 totally outside, so it is k plus k alpha equal to 0. Okay, equal to 0. Now we can simplify this inner term, so minus 1 plus j root 3 is multiplied by, what are the constant terms? Okay, 1 minus 3 minus 2, and this is minus 4, so k minus 6 is the real part, I think, and minus 2 plus 4. Okay, so j 2 root 3, that is the imaginary part, plus k alpha equal to 0. Slightly I'll solve it little bit more. Okay, इसको थोड़ा सा और अगर simplify कर देंगे हम. Okay, so then what I should be getting, minus 1 into k minus 6, that is minus of k minus 6. Okay, then minus j 2 root 3. Okay, then plus j k minus 6 into root 3. Okay, and then j square will be minus 1, so next term will be minus, okay, 2 root 3 into root 3 will be 3, so 2 3s are 6, and then plus k alpha equal to 0. Okay, so just open up the expressions now. Okay, imaginary terms को हम एक साथ कर लेंगे, right? So we have minus k plus 6 and minus 6 plus k alpha, and then plus j root 3 को common लिया, तो k minus 6 minus 2, तो k minus 8 equal to 0. Okay, k minus 8 equal to 0. Question is alpha, na? Question is alpha. Okay, so now right hand side is 0, so both the real and imaginary part is 0. यहाँ पे तो 6 6 cancel हुआ. Okay, minus k plus k alpha, okay, plus j root 3 into k minus 8 equal to 0. That means k minus 8 has to be 0, so k equal to 8, imaginary part. Okay, and then minus k plus k alpha also equal to 0. Okay, so k alpha is k 8 cancel हो जाएगा, alpha will be 1. Okay, solving it, alpha will be 1. Okay, solving it, alpha will be equal to 1. Okay, solving it, alpha will be equal to 1. That's it. ठीक है, that's it. ठीक है. Or the next approach I already told you, you can replace s by s minus 1. Okay, and then you have to solve for the marginally stable condition, that is inner product equal to the outer product, but after replacing s by s minus 1. Okay, so either there you have to do calculation or here you have to do calculation, but I told you something new because that is the regular approach to keep doing. Okay, so these are the questions of the control system. Yeah, so now let's move ahead. You know, the control system was on a moderate side, I will say. Some questions are lengthy. It's not very difficult, but some questions are lengthy. Okay, digital was also normally easy to moderate. Digital में ज़्यादा कुछ ऐसा खास नहीं था except one question or so. Okay, now we'll move towards the signal and systems. Okay, so now let us continue our question discussion from signal and systems. Okay, there are some good questions also from signal, others are moderate level. Let's have a look into it, starting with our MSQ question, multiple select question for 1 mark. For a causal discrete time LTI system with the transfer function given to you 2z square plus 3 upon z plus 1 by 3 z minus 1 by 3, which of the following statement is or are true? Okay, so 2 of the options are talking about initial and final value. Okay, whether the system is stable or whether the system is minimum phase. Okay, so very clearly if you try to calculate the poles and zeros, okay, let me write down the poles here. So what are going to be poles? Z is equal to minus 1 by 3 and plus 1 by 3. So Z is plus minus 1 by 3, and for both the poles, okay, for both the poles, mod Z less than 1, system is already given to you be causal. Okay, for a causal system to be stable, all the poles should be inside the unit circle. Should be inside the unit circle. So it is hence stable. Okay, so D to correct hai ji. Okay, now what about the zeros as well? What about the zeros? So if you try to calculate the zeros, you are going to get the equation 2z square plus 3 equal to 0, and z is equal to under root of minus 3 by 2, and that is plus minus under root of minus only j under root 1.5. Okay, so when you calculate the modulus of z, under root 1.5 is definitely greater than 1. Okay, the modulus of z greater than 1. Okay, so zeros outside unit circle. So system cannot be minimum phase, because for a minimum phase system, all the poles and zeros are inside unit circle. Okay, so it is non-minimum phase. Okay, it is non-minimum phase. So B wrong ho gaya. Okay, now initial and final value. Okay, to be taken up. So what is the initial value? Okay, I have h of z is given by, acha, one more thing. Final value we can, see, you can apply the final value theorem. Okay, or you can directly conclude a thing that whenever all the poles are inside the unit circle, final value is going to be 0. Okay, that is very much clear. Or you can apply one more thing. Okay, final value given by limit z tending to 1, z minus 1 into hz. Okay, into hz, and that is going to be, if you simplify from here also, it's going to be 0. Okay, but I can tell you that all poles inside unit circle. Okay, these are some techniques that you must know. Okay, all poles inside unit circle, and that leads to, of course, one obvious condition, stable, and that also leads to the condition that h infinity, the final value, is going to be 0. Okay, so C is correct. Initial value ke liye, okay, what is the hz given to me? Yeah, let me directly write down initial value h0, and that is given by the formula limit of z tending to infinity h of z. That is the initial value theorem. Limit of z tending to infinity, hz is 2z square plus 3 upon, if I multiply, if I convert into quadratic, this is going to be z square minus 1 by 9, a plus b and a minus b. The z square minus 1 by 9. So when you solve for z tending to infinity, okay, degree of numerator denominator is equal, and that is why it's going to be the ratio of highest coefficient terms, so 2 by 1. So initial value is going to be 2, or you can solve by L'Hospital rule. Always remember, initial value theorem is applicable if the function is a proper transfer function. The degree of numerator, okay, less than or equal to degree of denominator. If the degree of numerator is more, okay, then the initial value theorem cannot be applied. Then we need to do some manipulation, as I have taught you earlier as well. Okay, so initial value is 2. Okay, so correct answer is A, as well as C, as well as D. There are 3 options correct here. There are the 3 options that is going to be correct, A, C and D. Okay, moving ahead to the next question. Okay. So now let us come to this question. A causal and stable LTI system with the impulse response xt produces an output yt for the input signal xt. Okay, produces an output yt. Okay, system is causal and stable. The output is given by what? The output is given by the input convolution with the impulse response. Okay, for input xt and the impulse response ht, the output is yt. Now, a signal x 0.5t is applied to another causal and stable system with impulse response h 0.5t. What is the resultant output? So, dear, output is always input convolution. Okay, input convolution impulse response. Now, use the property that x of alpha t, convolution of h of alpha t, time scaling property of convolution, is given by 1 upon mod alpha y of alpha t. Time scaling property in convolution is only applicable when you have equal scaling parameter. Okay, and that is what is given, 0.5 and 0.5. Okay, so if I take that, h of 0.5t, convolution x of 0.5t, convolution h of 0.5t will give you the new output, that is 1 upon 0.5 y of 0.5t, okay, and then I can write it as twice of y 0.5t. Answer is C, twice of y 0.5t. Okay, next one. Okay, this is a good question. This is a good question, and I'll tell you a little bit injustice has happened to this question after the final answer key. What sort of injustice I will explain you, but first let me solve this question. Okay, ultimately in the final exam, answer key it was given as MTA, marks to all, and I'll explain that. A continuous time signal 2 cos 8 pi t plus pi by 3 is sampled at the rate of 15 Hertz. The sampled signal XST when passed through a LTI system, okay, with the impulse response ht is given to you, produces an output x naught t. What is the expression for the output x naught t? अब एकदम step by step इसको लेते हैं. देखो, number one, what is the input given to me? What is the input given to me? That is 2 cos 8 pi t plus pi by 3. Okay. Now let's talk about the sampled signal first, and then I will modify this. Okay, what is my sampled signal? We all know that sampled signal, okay, let us say it has the Fourier transform xs omega. Let us solve in the frequency domain, and as per the sampling theorem, what is this xs omega? Okay, this xs omega is given by 1 upon ts summation of x of omega minus k omega s, okay, for all values of k. Okay, for all values of k, that means the sampled signal Fourier transform is 1 upon ts, sorry. What is the ts? Now, it is sampled at the rate of, fs is given to you as 15 Hertz. Okay, and fs, the frequency is also 1 upon time period. So, when I want to talk about 1 upon ts, that is directly 15. Okay, and omega s, let it be omega s only right now. Okay, summation goes from minus infinity. Let us take some term, suppose k minus 1 to x of omega plus omega s, plus x of omega plus x of omega plus omega s till infinity. Okay, so I will be needing different terms, x omega plus omega s, x of omega minus omega s, and till infinity. That is what the different terms I need. ठीक है, that is what the different terms I need. अब यहाँ पे आएंगे. Okay, यहाँ पे आएंगे. What is x omega? Okay, so you can solve the Fourier transform of cos omega t and apply the time shifting property. There will be a phase term coming up, or let me make it more simple to solve it. Okay, this xt, let me take it as, okay, 2, let me apply cos a plus b. Okay, so it's going to be cos a cos b. Cos pi by 3 is root 3 by 2. Okay, minus sin a sin b, cos a plus b, cos a cos b, minus sin a sin b, so minus sin 8 pi t into sin pi by 3. Okay, sin pi by 3 is root 3 by 2, and sorry, यहाँ पे था cos pi by 3, that is equal to 1 by 2. So 2 तो throughout cancel हो जाएगा, and your xt is cos of 8 pi t minus root 3 sin of 8 pi t. Correct है? ठीक है. Now, what is going to be the Fourier transform then? What is the Fourier transform of cos omega naught t? Pi delta omega minus omega naught, that is delta omega minus 8 pi plus delta of omega plus 8 pi. What about sin minus root 3? ये तो constant है. Sin omega naught t pi by j delta omega minus omega naught minus of delta omega plus omega naught. Okay, ठीक है, that is what I have. Okay, now I have the x omega, and if I have x omega, I can also write down x omega plus omega s, x omega minus omega s. But before writing it, now let us see that this sample signal is going to be passed through a LTI system. Okay, and because the sampling function is going to come, so this LTI system somehow corresponds to filter, a low pass type of filter. Not exactly, it's going to be low pass. There is a shift here, but if I discard this, normally if you only take sampling function, it corresponds to the impulse response of low pass filter. But somehow it's going to be filter. Okay, इसलिए not all particular terms will be coming up. So before writing all terms, okay, let me simplify this impulse response. What is the ht given to me? Now ht is given by sin 2 pi t upon pi t into cos of sin 2 pi t by pi t upon into cos of 38 pi t minus pi by 2. Okay, so now what's this? Acha, let me even modify it. So this looks like multiply and divide by 2. So this is going to be 2 sin 2 pi by 2 pi t upon 2 pi t, so that you get the sampling function sin theta by theta. Acha, let's simplify this na. Cos theta minus 90 या cos 90 minus theta is sin theta. Okay, तो इसको simple कर देते हैं. Let this be written as sin theta. Let this be written as sin theta. Okay, now this is further equal to how much? To sampling theta, sampling 2 pi t. And what is sin theta? Sin theta is given by e raised to the power j theta minus e की power minus j theta divide by 2j. ठीक है, तो यहाँ पे 2 कैंसिल हो जाएगा. Let me write down the Fourier transform. You will just use this formula. What is the Fourier transform for sampling function? So for the very common and important functions, Fourier transform formula must always be known to us. Okay, for sampling at, it is given by pi by a rectangular function rect of omega by 2a. Okay, so h omega कितना हो जाएगा यहाँ पे? I've just cancelled 2 से 2. Okay, so I have 1 upon j extra. Now for sampling 2 pi t, it's going to be pi upon 2 pi. Okay, into rect of omega by 2a. The rect of omega by 2 to the 4 pi. Okay, now not only this, it is multiplied by e power exponential term in the time domain. Exponential term in time will correspond to frequency shift. So when you multiply by e power j 38 pi t, there will be a shift here. There will be a frequency shift here, and omega would be written as omega minus 38 pi. Okay, then similarly इसको common रखते हैं. Okay, then minus of rect of omega e power minus j omega naught t omega plus omega naught, frequency shift property basically. Okay, so this is how it looks like. Pi to pi cancel करेंगे. So dear, your h omega na, it is 1 upon 2j. It is 1 upon 2j rect of omega minus 38 pi upon 4 pi minus rect of omega plus 38 pi upon 4 pi. Okay, so that's what it's going to be, a filter. Now when you sketch the amplitude of this function, magnitude response of such a system, let me have a quick sketch of it. Okay, this question takes time. I am deriving it from scratch actually. Okay, because there was a lot of discussions around this question after the final answer. So I am deriving this question from scratch. Okay, so देखो, rect of omega minus 38 pi, a shifted rectangle centered at 38 pi and having the total width of 4 pi. This is 38 pi and there should be a total width of 4 pi. Total width 4 pi hoga, so if this is 36 and if this is 40. Okay, and let me draw the modulus of h omega. Yeah, h omega bhi rakhna hai, to no problem. I'll just write down the value. Okay, so how much value here it is? 1 by 2j. Then minus of rect omega plus 38 pi. So that is a left shifted rectangle. Okay, centered at minus 38 pi. Again having the width 4 unit. So this should be minus 36 pi and minus 40 pi. And this is having the coefficient minus 1 by 2j. ये minus के साथ लिख दिया. Okay, so it's a type of band pass filter that is coming up. Okay, it's a type of band pass filter coming up. Okay, so only those frequencies, or this is the impulse, this is the frequency response of the system. So only those frequencies of the sample signal which is between this 36 pi to 40 pi or minus 40 pi to minus 36 pi, that will be coming in the output. यही हमें समझना था. Okay, so dear, just write down x omega. Okay, what is x omega now? Okay, with reference to this, if I write down x omega, that is x omega already written here. Okay, just let me copy it here step by step. Okay, pi, देखो ये तो नहीं आने वाला है x omega, that is very crystal clear. Okay, x omega, that is pi delta omega minus 8 pi plus delta omega plus 8 pi minus root 3 pi by j. Okay, minus root 3 pi by j. Delta omega minus 8 pi. Delta omega minus 8 pi minus delta omega plus of 8 pi. Okay, ये हो गया. ठीक है जी, done है. Okay, now we know that this is the impulse at plus minus 8 pi. Plus minus 8 pi, that is not the output of the filter. Only the frequency between 36 pi to 40 pi will be considered. Okay, that much is very clear. Okay, so now if I take x of omega नेक्स्ट क्या लेना है मुझे, ओमेगा प्लस ओमेगा एस, ओमेगा माइनस ओमेगा एस. ओके, सो व्हेन आई टेक एक्स ऑफ ओमेगा minus omega s, okay, that is x of omega minus, what is omega s? Hey, what is omega s? That is 2 pi fs, so that's going to be 30 pi. Okay, in the omega domain that is 30 pi. So यहाँ पे हम लिखेंगे omega minus 30 pi. Okay guys, and then I will write down one more case, x omega plus omega s. Okay, that is x of omega plus 30 pi. That is how much. ठीक है, तो x of omega minus 30 pi ये कितना हो जाएगा, that is pi delta omega minus 30 pi करेंगे, so this is going to become 38 pi. This is going to become minus 38 plus 8, so minus 22 pi. Okay, minus root 3 pi by j delta omega minus 38 pi delta omega minus 22 pi. यहां पे आ जाएंगे तो आई वुड बी हैविंग पाई डेल्टा ओमेगा प्लस 30 पाई करेंगे तो प्लस 30 पाई करके हेयर यू गेट ओमेगा प्लस 22 पाई. यहां पे आ जाएगा प्लस 8 प्लस 30, दिस इज गोइंग टू बी 38 पाई. ओके, माइनस रूट 3 पाई बाई जे डेल्टा ऑफ ओमेगा. ओके, यहां पे प्लस 30 कर रहा हूं मैं, सो दैट्स गोइंग टू बिकम प्लस 22 पाई माइनस डेल्टा ओमेगा plus 38 pi. Okay, that is how it is. Okay, now definitely if you have a look into the waveform as well dear, what are the terms that is going to be passed? What are the terms that is going to be passed? This is the impulse at 8 pi minus 8 pi, so these impulses are discarded. Okay, now omega minus 38 pi ये pass होगा, 22 pi not passed, 38 pi passed, 22 pi not passed. Again 22 pi not passed, minus 38 pi, this is the impulse at minus 38 pi, so that is passed. Minus 22 pi not passed, 38 pi passed. जो pass होगा. Now whatever is the positive frequency, that is multiplied by 1 by 2j, and on the negative side multiply by minus 1 by 2j. So if I write down the final x naught omega, see they have given you that x naught t is the output and that will have some Fourier transform, suppose x naught omega. So what is going to come? Okay, this term will come. Okay, this is on the right side, तो 1 upon 2j के साथ multiply होगा. Okay, so I will have 1 upon 2j pi delta omega minus 38 pi. डन है, ठीक है. देन यहां पे भी ओमेगा minus 38 pi, so that is also multiplied by 2j, तो minus root 3 pi by j minus root 3 pi by j. ओके, डेल्टा ओमेगा माइनस 38 पाई, डेल्टा ओमेगा माइनस 38 पाई. डन है जी, डन है, ठीक है. सो दीज टू विल कम. नाउ लेट्स कम टू दिस वन. ओके, पाई ये भी आ जाएगा बट दिस ऑन द नेगेटिव साइड, सो मल्टीप्लाइड बाय माइनस 1 बाई 2j. ओके, देन दिस इज पाई डेल्टा ओमेगा प्लस 38 पाई, डेल्टा ओमेगा प्लस 38 पाई. ओके, एंड देन व्हाट इज द नेक्स्ट दैट इज गोइंग टू कम? ओके, दिस इज गोइंग टू कम अप. ओके, ये आ जाएगा एंड दैट्स गोइंग टू बी मल्टीप्लाइड बाय माइनस 1 बाई 2j, तो मैंने बाहर लिख ही दिया है. सो माइनस रूट 3 पाई बाई जे. ओके, माइनस माइनस प्लस हो जाएगा, प्लस रूट 3 पाई बाई जे, दिस इज माइनस, दिस इज ऑल्सो माइनस. ओके, देन डेल्टा ओमेगा प्लस 38 पाई. ओके, नाउ सी हाउ वी कैन रीअरेंज द टर्म्स हियर. ओके, नाउ वी कैन सी हाउ वी कैन रीअरेंज द टर्म्स हियर. डेफिनेटली ओके, दिस इज गोइंग टू बी विथ पाई बाई जे. ओके, दिस इज गोइंग टू बी पाई बाई जे. एक फैक्टर यहाँ पे मिस हो गया आई थिंक, एंड दैट इज द फैक्टर ऑफ 15. ओके, ये 15 आउटसाइड आएगा एक्सेस ओमेगा में. ओके, सो 15 ऑल्सो लेट मी मल्टीप्लाई हेयर कंप्लीटली. ओके, हेयर ऑल्सो लेट मी मल्टीप्लाई बाय 15. ओके, सो 15 डिवाइड बाई 2. ओके, नाउ बी वेरी केयरफुल, नाउ वेरी केयरफुल. पाई अपॉन जे ये आ गया, पाई बाई जे. हेयर ऑल्सो यू विल गेट पाई बाई जे, तो पाई बाई जे कॉमन, डेल्टा ओमेगा माइनस 38 पाई. ओके, और माइनस डेल्टा ओमेगा प्लस 38 पाई. ओके, नाउ वी नो व्हाट दिस करस्पॉन्ड्स टू. लेट्स कम टू द नेक्स्ट. ओके, 15 बाई 2 आउटसाइड है, ब्रिंग द जे इनसाइड, जे स्क्वायर इज माइनस 1, तो माइनस माइनस प्लस हो जाएगा ये, तो दैट्स प्लस रूट 3 पाई. ओके, दैट्स गोइंग टू बी प्लस रूट 3 पाई. ओके, एंड विथ प्लस रूट 3 पाई आई हैव गॉट डेल्टा ओमेगा माइनस 38 पाई. ओके, यहां पे भी देखेंगे 15 बाई 2 आउटसाइड, bring the j inside, j square is minus 1, already there is minus, तो माइनस माइनस ये प्लस ही रहेगा, तो प्लस रूट 3 पाई के साथ आएगा अनदर टर्म डेल्टा ओमेगा प्लस 38 पाई. Okay, so now dear, what is going to be x naught t? What is going to be the x naught t? Okay, that is 15 by 2. Now pi by j, okay, this is the Fourier transform of sine. Okay, clearly sine 38 pi t. Okay, plus root 3. Now pi of into this term, this is the Fourier transform of cos omega naught t, cos 38 pi t. Cos 38 pi t. Okay, now shift the 1 by 2 inside. Shift the 1 by 2 inside. Okay, then you can write this as sine 38 pi t into 1 by 2. Okay, plus cos 38 pi t into root 3 by 2. Now how you can write it up? Okay, this can be written as cos 60. Okay, so sin a cos b plus cos a sin b. Okay, sin a cos b plus cos a sin b. Okay, sin of a plus b. Okay, sin of 38 pi t plus pi by 3, 60 degree ना. देखो sin a cos 60 degree plus cos a sin b, sin 60 degree root 3 by 2. Okay, this is sin 38 pi t plus pi by 3. But now sin 38 pi 3 plus pi by 3 c. ठीक है. Now what happens? Okay, this is convertible. This is convertible to you add plus and minus 90. Okay, you will get this answer as 15 cos 38 pi t minus pi by 6. Yeah, maybe if you do plus minus 90, that is one case, or plus minus 90 नहीं करना है, तो you can also assume this formula as cos a cos b plus sin a sin b, cos of a minus b, cos of a minus b, cos a cos b. So this is cos 30 degree, root 3 by 2 30 degree पे आता है, that is pi by 6. तो cos a minus b, that can also be taken as cos a minus b. Now you know what originally answer key was given by IIT. Okay, originally IIT gave this answer 38 pi by 3 minus pi by 6, correct? Okay, but there are two options correct. Okay, C is also correct. Question क्या है? MCQ है. MCQ only one can be correct. So students challenged it. Okay, they accepted the challenge, but they gave a blunder response to the challenge. They accepted the challenge, and this question was given marks to all. Maybe because of the logic MCQ है तो more than one option कैसे correct होगा? अरे but dear, it has happened in the past year also. No problem. Question is correct. Very good. Many top students have attempted this and wasted 5 to 6 minutes. Okay. Maybe they also got 2 marks, and anybody who did not attempt the question, उसको free के 2 marks मिल गए. That is injustice with good students ना. So that is why what IIC could have done. Checking the answer is in their hand, और ऐसा past में हो चुका है कि maybe 2 options are matching. So whether you attempted C or whether you attempted D, maybe the C or D is different in the official paper. Maybe there it is A or C. ये पूरा shuffled होता है. But if 2 options are correct, whether you attempted C or whether you attempted D, both should get the marks. ठीक है. अगर किसी ने B mark किया या A mark किया, that should get negative mark. Okay. किसी ने attempt नहीं किया, that should be 0 mark. That could have been done, but they have given MTA. Okay. That was a big injustice. Okay. So both options actually, dear, are correct here. C is also correct. D is also correct. So they could have put it as C or D. Anything you mark, you will get it. कोई भी आप mark कर दो. Software में ऐसा हम लगा देंगे कि C mark किया या D mark किया है. Okay, you will get it. But ठीक है. What happened was history. Let's move ahead to the next question. But very good question. Okay, and I've derived it from very fundamental scratch. चलो. Okay, the next question, MSQ question for 2 mark. इसका भी आंसर की करेक्ट हुआ था. Okay, but this was not MTA. There was a corrected answer. I'll tell you what is the logic of that. 3 questions in signal and system got correction. Okay. The radian frequency value for which the discrete time sinusoid signal A cos omega n plus pi by 3 has a period of 40. Okay, the period is going to depend on the frequency, not on the phase, not on the phase shift. So period should be 40. I'll explain you. If I take option number A, okay, where omega has been taken as 0.15 pi. Now a discrete time signal is not, a discrete time sinusoid is not always periodic. It is periodic only if 2 pi by omega is a rational number. So when I simplify, it's going to be 200 by 15, 100 से multiply किया, cancel by 5. So this is 40 by 3. A discrete time sinusoid is periodic if 2 pi by omega is a rational number. So here it is a rational number, so definitely periodic hai. But period cannot be non-integer. In discrete time, the time can only take integral values. Okay, so the period cannot be 40 by 3. Okay, so what is the time period then? Time period is the, is written as, okay, the smallest integer, fundamental period की बात करें, okay, smallest integer k such that 40/3 into k, okay, becomes integer, because the idea is if the signal value is going to repeat at 40/3, it will repeat at 80/3, it will repeat at 120/3, it will keep repeating, na? Okay, so that is why if you take k equal to 3, okay, you will get the period as 40, and this is known as the fundamental period. Okay, so A तो definitely correct है, इसमें period 40 आएगा. Okay, now coming to B, similarly, now let's solve it. 2 pi upon 0.45 pi. Okay, pi cancel, 200 by 45, we again cancel by 5, so this is going to be 9, 40. Now 40 by 9, I can multiply it by 9 so that I get the period 40. Okay, so that I get the period 40. ये भी correct है. Okay, coming to option number C. Okay, 2 pi upon 0.3 pi, pi cancel, this is 200 by 3. Okay, this is 200 by 30, sorry, it's basically 20 by 3 na, directly. Okay, now I multiply 20 by 3 into 3 and it is 20. So here the period is not 40, here the fundamental period is not 40. Okay, now originally देखो D तो wrong होगा ही, पहले मैं D पे आ जाता हूँ. Okay, then what is the D answer? 2 pi upon 0.225 pi. Okay, so this is going to be pi cancel, 2000 divided by 225, cancel with the how much? Cancel with 25, so this is 9, and if you cancel this by 25, it is 80. Okay, now 80 by 9, you cancel with 9, you get the period as 80. Okay, so here the period, fundamental period itself is 80, so D to wrong hai. Originally what is the answer key given by them is A and B. Originally the answer given by them is A and B. If the question says tell the fundamental period, then A and B is correct. But again, period means normally any value of time. Okay, it's a standard thing written in every textbook, after which repetition occurs. Here the fundamental period is 20. Option number C पे आएंगे. Fundamental period is 20. Okay. But if a signal value repeats after 20, it repeats after 40 also, it repeats after 60, and etc. And all of them are period. Although they are not fundamental period, by default it can be assumed as a fundamental period question, but they have to be very clear, especially MSQ question, and that is what created a doubt in the student's mind. And this was a very valid doubt. This had to be challenged, and the challenge was accepted. And the answer key that came up later on was, okay, whether you marked AB, okay, or whether you marked A, B or C. Okay, both the category of students will be given mark. Okay, both the type of students will be given mark. Okay, whether you marked AB or whether you marked ABC. Okay, this is okay. AB क्या है तो भी ठीक है, fundamental period by default it is assumed as fundamental. Okay, but उन्हें mention नहीं किया, that is their fault, they didn't mention fundamental. If somebody solved using period concept, okay, they are also okay. Okay, so they are also okay. Here period is 20. So it can be 20, 40, 60 repetition will occur at all of them. Okay. So ABC is also correct. AB or ABC, both were given in the official final corrected answer key. MSQ question 2 mark. Okay. Next question here. This one is simple, but you know guys, interestingly, अच्छा यहाँ पे तो हमने correct करके दिया है इसको. Okay. You know, interestingly, this question was also given marks to all. Why? Very simple question this is, and it has a very simple solution. There was a typing error in the question. See, blunders has happened this time in the questions. The typing error was between 0 to -1. We all understand, you know, even I think if you solve this question also, no, you will not take that into account also. Kya plus 0.5. There was plus 0.5. Okay, there was plus 0.5. This has to be minus 0.5. This has to be minus 0.5. So on the account of typing error, this question was empty. Again, those students who did not even attempt the question, जिनने Fourier transform नहीं पढ़ा था या जिनके पास time नहीं बचा था, उनको free के marks मिल गए. That is injustice happening. यार, they have to be careful in making the paper. Okay. But although guys, it is very logical. Even if you did not notice, you can solve the question. I think, you know, while solving, those who solved na, they also did not notice कि minus से plus point. Well, logical ना यार. इतना तो basic सबको पता है. -1 और -1 and 0 के बीच में, it can be only minus 0.5. Chalo, now what is the question? There are two signals xt and yt, and if xs is the Fourier transform of xt, then what is the Fourier transform of yt? So first of all, I need to relate these two waveforms. भाई सबसे पहले चीज क्या करना है? I need to relate these two waveforms. And how to relate this? This has a duration of 4. Okay, this has a duration of only 1. So there is definitely compression. There is definitely compression. Okay, what I will do is first let me shift it. Okay, so that let me make one of the point at origin. Okay, so if I shift by 2 units, left shift by 2 units करेंगे. So if I do the left shift by 2 units ना, देखो dear, what I'm going to get, if I do the left shifting here by 2 units, I will get this waveform from -4 to 0. This is 0, this is -4. Okay, ठीक है, left shift by 2 units. So when you left shift, this becomes y of t plus 2. Okay, this has the amplitude 1. Okay, now what I'm going to do now, compress by 4 times. Okay, now I'm going to compress it by 4 times. So when you compress it by 4 times now, okay, so -4 will come to -1, 0 by 4 will be 0 only. Okay, and amplitude does not change, only we are compressing the time axis. Okay, now compression by 4 means y of, ये था y, तो y of t by 4. ठीक है, yeah, I think I should do reverse. ठीक है, I think I should do reverse, it will be more easy, I'm sorry. ठीक है, ये भी ठीक है, later on we can swap it, but I need to relate yt in terms of xt ना. Okay, so what I will do is, okay, here let me shift it. Okay, let me bring the center, because this is symmetric, this is centered at origin. Okay, so first what I'm going to do, I'm going to do the right shifting of this. Right shift by how much? By 0.5. Okay, when you right shift by 0.5 ना, when you right shift by 0.5, देखो ये कितना हो गया. Okay, this will be -0.5, this will be +0.5, center will be at origin. Okay, this is right shifted. Okay, this is right shifted. Now what is the right shifted waveform known as? X of t minus 0.5. Okay, now I need to make this duration -2 से 2, I mean expansion by 4. Okay, here I need to do the expansion by 4. Expand by 4. Okay, so let me expand this by 4. Okay, let me expand this by 4. So this is going to now become, okay, -2 से +2. Okay, now expansion means what? Okay, t by 4. Okay, वहां पे मैं उल्टा बोल रहा था compression, तो compression would be 4t, but here I'm expanding, तो t will be replaced by t by 4. Okay, so x of t by 4 minus 0.5. X of t by 4 minus 0.5. Okay, but this is having the height, yeah, amplitude -1. I have to make it +1. So amplitude scaling bhi karenge. That means, dear, now I can write down yt is negative of this one. Just negative of this one. Minus of x of t by 4 minus 0.5. Okay. T by 4 minus 0.5. Okay. Chalo. Okay. Now xt has the Fourier transform x omega. Okay, so x of t minus 0.5. Okay, first again start with the precedence rule. Shifting and scaling, let me do the shifting first. Okay, so that's going to become x omega. Okay, e raised to the power minus j omega 0.5. Okay, time shifting property applied. Okay, then x of t by 4 minus 0.5. Okay, time scaling property of Fourier transform. 1 by a, 1 by 4. Okay, x of omega by a, everywhere omega will be replaced by omega by a. तो ये कितना हो गया? Okay, this is going to become, and let me apply the minus also here. So this will become minus 4 x of 4 omega e power minus j, 4 omega into 0.5, so e power minus j 2 omega. Okay, let's match the answer. Minus 4 x 4 omega. Okay, it is in the f domain, no problem. Okay, so in the f domain it is going to become minus 4 x of 4f. Omega is 2 pi f, so here it becomes e power minus j, okay, 4 pi f. Minus 4 e power minus j 4 pi f x of 4f. ठीक है, डन है? Yeah. So correct answer is option number A. The very correct answer is option number A. Let us get moving ahead with the next question. Okay, a DFT 2-mark question, good one this is again. Okay, the relationship between any n-length sequence xn and its corresponding endpoint DFT xk is given to you. Xk is equal to Fourier of xn. Okay, now yn is, okay, Fourier of 4 times Fourier. Okay, chalo, so let's solve this by the duality property. Okay, if you apply duality, you see, either you can remember the standard results, if you can be formulative in the approach ki multiple time Fourier transform dene se kya hoga, or let's try to solve it, okay, by the duality property. let us say xn has the DFT that is xk. Okay, so now when you apply the duality, अच्छा, this is the first Fourier transform. भाई ये हो गया first Fourier transform, right? ठीक है, Fourier transform of xn that is given by xk. Okay, that is given by xk. ये यहाँ पे लिखे है ना? That is the one-time Fourier transform. Now, when you apply the duality, that means when you convert this k function into the n function and again take the Fourier transform, it is given by nx of minus k. This is replaced by minus k and here k was replaced by n. Okay. Okay, so by duality I have taken one more time Fourier transform. So this is the second Fourier transform. Now what to do, dear? Okay, what to do? Let us say that this signal, okay, is x1n. एक एक करके चलते हैं, हमें yn तक आना है ना. This is some signal x1n, okay, whose DFT you have computed as x1k. ठीक है. Now again apply duality. Keep applying. Okay, so x1, capital X1n, k replaced by n, will have the DFT capital N. Capital N is the length of the sequence, जो last में 4 put कर देंगे. Okay, x1 minus k. Okay, this n will become the minus k. How many times? This is the third Fourier transform. Okay, now one more we'll have to take. Achha, if this is the third, let us say now this signal of time is x2n. Its Fourier transform is x2k. Its Fourier transform is x2k. So now I have n. Okay, yeah, directly हम वापस से duality apply कर रहे हैं. I think the last time. Okay, so now capital X2n, that will have the DFT n x2 of minus k. N x2 of minus k. Okay, ठीक है. And this is the fourth one. Okay, this is the fourth one. ठीक है. All right. ठीक है. So if this is the fourth one and yn is 1, 2, 3, 4, fourth Fourier transform, that means पहले तो ये कितना हो जाएगा? What is this calculation equal to? N x2 minus k. Okay, n x2 minus k. What is x2 minus k? That is capital X1. x2 is capital X1n, na? Okay, so that is capital X1 minus k. That is further equal to, now what is capital X1? That is equal to, what is capital X1? N x minus k, n small x minus k. यहाँ पे मुझे minus k रखना है, तो minus minus हो गया plus. Okay, so this is actually n square xk. Okay, now they are treating it as a time function. So what is yn? That is n square xn. Yn is n square xn. Okay, yn. Okay, now what is the value of y? Capital Y0. Okay, देखो. Yn is given by n square of xn. यही आया, ठीक है. Okay, now yn has some DFT yk. Okay, what is the value of y0? Now for the first sample of DFT y0 is always given by the formula, that is summation of yn. Okay, that will become summation of n square xn. Okay, and hence y0 is equal to n square summation of xn. N is the length है यहाँ पे 4 square into summation of all values of xn 1, 2, 1, 3. Okay, so I have 1 plus 2 plus 1 plus 3. So this is equivalent to 16 into 3, 4, 7, 16, 1, 1, 2. Answer should be 112. This answer is 112. Numerical answer type question. Good one from signals. The answer is 112. Done hai ji? Okay. Alright. Let's move ahead to the next question. Number 35. Okay, now jumping to electromagnetics, and let me tell you, electromagnetics this time was not difficult. It was a easy to moderate paper only. Consider a lossless transmission line terminated with a short circuit, okay, as shown in the figure below. As one move towards the generator, okay, from the load, यहाँ से generator की तरफ जाएंगे, the normalized impedance is ZNA, ZNB, ZNC and ZND. Okay, what is the normalized impedance? Dear, normalized impedance means, okay, the actual value of impedance, okay, normalized input impedance, okay, actual input impedance divided by Z0. ठीक है, अब यहाँ पे ध्यान देना आप यहाँ पे. Okay, ZNA. Okay, let me start with the first one, ZNA. Okay, this ZNA here the load is short circuited. Okay, and for short circuited, what is the formula? What is the input impedance of a short circuited line? JZ0 tan beta L. Achha, everywhere tan beta L is going to come. What is beta L? Okay, beta L is 2 pi. Beta is 2 pi by lambda. Length For all the section length is lambda by 8. So lambda lambda cancel, this is like pi by 4. So whenever tan beta L will come, tan pi by 4, we know it's going to be 1. Okay, so Z in A is going to be JZ0 because tan beta L is 1. Okay, so Z in A, normalize karenge. When you normalize with Z0, divide by Z0, it's going to be J. And guys, it's a 1 mark question. If you want, you can stop here. Answer is A. Okay, the first option matches with Z in A. Actually, in exam time, you should not calculate Z in B, Z in C, etc. But abhi ke liye nikal lete hain. Now, what is going to happen, dear? Now, what is going to happen? Okay, now have a look into the next portion. Again, having the length lambda by 8. Okay, and terminated with the load JZ0. Terminated with the load. Okay, JZ0. Okay, this is having again the length lambda by 8. And now I want to calculate Z in B. Okay, so what is the Z in B formula? Normal formula, the line formula is Z0 ZL plus J Z0 tan beta L, general input impedance formula, divided by Z0 plus J ZL tan beta L. But dear, again the length is same, so beta L will be pi by 4, tan beta L will be 1. Okay, tan beta L will be 1. So this time it is going to be Z0. Okay, ZL plus JZ0. Acha, what is the ZL? This is the load now. So let me put down the value of the load impedance, that is JZ0. Okay, plus JZ0 tan beta L 1 upon Z0 plus JZL. Okay, ZL ka value JZ0 and tan beta L is 1. So you know how much is this equal to? Z0 JZ0 plus JZ0, so 2JZ0, but denominator if you see, na, J square minus 1, so Z0 minus Z0, 0, 1 upon 0 infinity, so Z in B tends to infinity, so even if you normalize it's infinity, so answer is B. Okay, similarly you can calculate for C and D. Okay, similarly you can calculate for C and D. Okay, now for C what will happen? You have taken the load which is, now Z in B will be acting as a load which is open circuited. Okay, so you will apply the open circuited formula. So I hope you can complete that. It's done. Answer is A. 1 mark के लिए इतना ही effort करना चाहिए ना, मतलब not even this was required, यहीं से आप match कर देते. Okay. Only by this much knowledge it is sufficient. Done है जी. Next one. Let I and J be the unit vectors along x and y direction respectively, and let A be the positive constant. Which of the following statement is true for the vector fields F1 and F2? Okay, conservative. Which of the following is electrostatic field? Electrostatic field. And electrostatic field has the property, okay, that it is conservative in nature. Electrostatic field has the property that, okay, the curl of F must be 0. It is conservative in nature. So very basic question, guys. It is a question on the calculation of curl. It is a calculation on the question on the calculation of curl. Del cross F1. Okay, let us solve the curl regularly by the determinant formula I, J, K. Okay, partial derivative terms del by x, del by del y, del by del z, and I component, that is the x component, that is AY, y component, that is AX, and there is no z component. So you know when you solve it, okay, because it's only in 2D, you're going to get the answer as k cap del by del x of AX is A, del by del y of AY is A. Okay, the answer is going to be 0. The definitely F1 to conservative hai. Okay, but we have to check for F2 also then. Okay, we have to check for F2 also then. So what is the del cross F2? The del cross F2 is then given by I, J, K, okay, del by del x, del by del y, del by del z, and AX. Dekho, what is the next one? That has the component AY minus AX and 0. Again, this is in 2D. When you solve, देखो I cap del by del y 0, del by del z of AX will be 0. J cap के साथ इसलिए मैं नहीं रख रहा. Del by del x 0, del by del z of AY 0. Only K cap term will come. Del by del x of minus AX minus A. Del by del y of AY again A. So it actually becomes minus 2A. I mean whatever it is, actually it is not equal to 0. So that means F2 is not conservative. So what is the correct answer then? Then answer is A. Only F1 is conservative, F2 is not conservative. So it is a simple calculation based question, I can say. It is a simple calculation based question. Correct hai ji? Okay. Next question. 37th ready for you. Okay, 2-mark question, but if you know the direct concept for this, then it's a very easy for you. One-liner answer. A lossless transmission line with a characteristic impedance 50 is terminated with an unknown load. The magnitude of the reflection coefficient is 0.6. As one move towards the generator from the load, the maximum value of the input impedance, okay, the maximum value, there is a lossless transmission line, okay, terminated in an unknown load. There is some unknown load ZL. Okay, now what else is the data given to me? That the line is having the impedance 50 ohm, it is lossless line, and the reflection coefficient mod k, let me call it as mod k, that is 0.6, okay, the load reflection coefficient. Okay, as one move towards the generator from the load, okay, towards the generator from the load, okay, what is, now suppose this is some point P, okay, what is the input impedance at any point? Okay, at any point at a particular distance. So for, you can calculate the impedance at any point on the line, provided you know the distance from the load end. And suppose this distance from the load end is suppose L dash. Okay, then it is given by the formula Z naught, the same formula that I've written, ZL plus JZ naught tan beta L dash upon Z naught plus JZL tan beta L dash at any point on the line. Okay, let P be any point on the line. Okay, now at different points you will be getting different impedance. The maximum such value is given by, okay, the maximum such value of the impedance and the minimum such value of the impedance solved as per calculus. The maximum such value turns out to be S into Z naught. The minimum such value turns out to be Z naught divided by S, where S is the standing wave ratio. Now what is going to be the value of S? 1 plus mod k upon 1 minus mod k. Mod k ka value hai 0.6. So 1 plus 0.6 upon 1 minus 0.6. So this is 1.6 upon 0.4. That is 4. Standing wave ratio 4 hai. So maximum such value is 4 into 50. And that is 200. If they ask minimum, then aap Z naught by S use kar lenge. But as of now, the answer is 200 ohms. 200 ohms. Done. So if you know that point, it's a very simple question. Otherwise, you will derive and you will take a lot of time. Okay. Next question, dear. 38. Okay. Yeah, basically from the wave propagation part. A uniform plane wave with the electric field, okay, is traveling in the air and relative permeability mu r equal to 1 in the plus x direction. Okay. It is incident normally on an ideal. Like, whenever any wave is incident on an ideal conductor, whether normally or whether at any oblique incidence, okay, whenever incident on a perfect conductor, the reflection coefficient is always minus 1. Basically, the formula is eta 2 minus eta 1 upon eta 2 plus eta 1, but eta 2 is 0 for a perfect conductor. That is why it is minus eta 1 upon plus eta 1, and hence it is minus 1. For a perfect conductor, intrinsic impedance is 0. The intrinsic impedance is 0. Okay? The intrinsic impedance part is 0 for a perfect conductor. Okay, dear? Okay, this is what? This is for a perfect conductor. This is for a perfect conductor. Okay? This is what I was mentioning. This must be 0. Done? Hai? Chalo, now next. Okay, what we know is the value of K. Now, what is the position of first null of the magnetic field? Okay, null of the magnetic field. Okay, yeah, minima of the magnetic field occurs where we should know that the minima of magnetic field will occur where there is the maximum of the electric field, and the maxima of the electric field, generally we write down the formula in terms of electric field. A transmission line we write down the formula in terms of voltage. Okay, it is given by the general formula theta k minus 2 beta max nikalna hai na, minus 2 beta d max is minus 2n pi. Okay, minus 2n pi. Now theta k, dekho, k is actually broken as mod k e power j theta k. So ye minus 1 hai na, I can write it as 1 into e power j pi. 1 into e raised to the power j pi. Okay, for the first null, that means first null means first maximum of electric field, I will put n0. The phase of the reflection coefficient is pi. Okay, minus 2 beta d max, that will be 0, and that is what is the value of the distance. What is the value of this distance? Okay, that is pi divided by 2 beta, pi by 2 beta. Okay, where e power minus j, this should be generally the term e power minus j beta x as the regular expression of wave we know. Okay, so what is the value of beta? Is 2 pi by 3. Okay, so pi divided by 2, 2 pi by 3, pi cancel hua, it is 3 by 4. Okay, it is 3 by 4. Okay, guys, options are slightly hidden here. मैं इसको थोड़ा सा uplift कर देता हूँ. हाँ, it is minus 3 by 4. Okay, it is minus 3 by 4. Okay, it is minus of 3 by 4. ठीक है. Why minus? Because of course the conductor starts from x equal to 0. We are looking on the region number 1. Okay, so that is why with the negative coordinate, the wave is traveling in the plus x direction. Okay, this is the boundary at x equal to 0. The wave is traveling in air. Yeah, clearly mentioned here. It is air. Here it is conductor. Okay, so this portion is x less than 0. This portion is x greater than 0. So coordinate wise negative aayega. Okay. The standing wave will be formed in the medium number 1 when there is a combination of incident and reflected wave. So minus 3 by 4 is the correct answer. ठीक है, और ये था conductor वाली बात, ideal conductor. Okay, you can derive using this, or always remember k is minus 1 whenever there is a perfect conductor wave, incident on a perfect conductor, whether normal incident or even at the oblique incidence. ठीक है. Next, what it is? Okay, yeah. So this is a good logical question. It's an aptitude question basically, you can say. Coordinates se question पूछ लिया इस बार. Consider the earth to be a perfect sphere of radius r. Then the surface area of the region enclosed by the 60-degree north latitude circle. 60-degree north latitude circle. Okay. Let me first take up a sphere here. Let me first take up a sphere here. Okay, to explain you the geometry of this question. Okay, the earth is a perfect conductor, a perfect sphere. That's what they are trying to specify here. Okay, now say this is the center. Okay, 60-degree north latitude. Okay, latitude agar 60 degree hai, latitude is measured from the equator na. Latitude will be normally measured from equator na. Okay. Okay, and this is the north pole. Okay, this is the south pole. अब हमें क्या बोला है? I want the कितना latitude था? 60 degree of latitude. So what will be co-latitude? In spherical coordinate system we have the coordinate na co-latitude. That is 90 minus latitude. Complementary angle के concept से. Okay, so let me take that much. Okay. This is what I mean. There. This is 60 degree. 60 degree, okay, north, okay, 60 degree north bola hai, that is the latitude. So how much is the co-latitude? That is 30 degree. That is 30 degree. I want the surface area of this much portion of the sphere. Okay. Okay, I want the surface area. Now, okay, the radius of course is fixed, that is r. So when you take any vector, okay, when you take any vector, okay, the normal vector to it, okay, when you take any vector normal to it, normally away, that is in the radial direction, that's going to be the AR direction. So along the radial direction, because the vector normal to the surface given to us is in the radial direction, along the AR, the differential area is given by r square sine theta d theta d phi AR. Okay, now what's going to be the total surface area? Okay, the total surface area, the total surface area is going to be, of course, the integral of this, okay, along the radial direction. So let's directly solve the integration part only. Okay, and that's going to be double integral r square sine theta d theta d phi. Okay, okay. Now, okay, because ultimately only the magnitude of ds is required to solve for the surface area. Okay. Direction is AR, that's what is known to us. Now, what about the coordinates? Okay, what about the limits of theta and phi? The theta will be and the phi. Okay, phi will be the full azimuthal angle. Okay, ये पूरा यहाँ पे तो आपको फ्लैट कर्व दिख रहा है, बट इट्स एक्चुअली सर्कल, इट्स अ स्फीयर ना. So if you take any point like this, it's going to be circle. Here also, it's going to split into multiple circles. Okay. So for completing every circle, we need the azimuthal range, that is 0 से 2 pi. Okay. I hope you know what is azimuthal angle, and colatitude is कितना 30 degree. Theta in the spherical coordinate system is colatitude, not the latitude. So if latitude 30, colatitude is up to latitude 60. This is up to 30. तो हमें 0 to 30 degree लेना है. That is 0 to pi by 6. Okay. That is 0 to pi by 6. That is 0 to pi by 6. Okay, so now let me solve this up. Okay, the value of r, that is fixed. Okay, r ka value fixed hai, that is radius, that is r square, so that is outside. Sin theta d theta, let's solve it in single step. Now integral of sin theta d theta minus cos theta. Okay, 0 se pi by 6. Integral d phi is phi, limit 0 se 2 pi. Okay, so this is minus r square cos pi by 6 root 3 by 2 cos 0 1 into 2 pi minus 0, that is 2 pi. So minus को अंदर adjust कर लेंगे. So this is r square. Okay, then shift the minus inside, that's going to become 2 minus root 3 by 2 into 2 pi. Okay, 2 also getting cancelled, so it can be written as pi r square 2 minus root 3. Pi r square, okay, 2 minus root 3, and hence the answer is C, pi r square 2 minus root 3. Okay, that is the correct answer. That is option number C. Yeah, so this was more like a coordinate system question. Okay, so interestingly, from a lot of years they were not asking a direct question on coordinate system, but that is why every time in the EMFT I specified ki always you have to start with the coordinate system only, even if direct question is not coming, but without coordinate system and without vector calculus. Okay, without vector calculus you can never be good. Okay, you can never be strong. You can never ever be strong. Just a second. You can never ever be strong in this subject. Yes. Chalo. Done. So there's a lot of questions discussed from my end, almost up to 39 questions. I discussed maths, aptitude. In the beginning we first took up the non-tech part aptitude, then we moved to maths. Then I had taken up the questions from digital, then control, then I went to signals, and this is electromagnetics. And now I invite Sanjay Rathi sir, and he'll be continuing the questions of network, EDC, analog, and then Saket sir will join for communication. That's it from my side. Okay, now you enjoy continuing the video with Sanjay Rathi sir. Okay, he's going to discuss network, EDC, analog. Thank you guys.
Thank you Rakesh sir. Hello students, this is Sanjay Rathi. I am going to discuss questions from network, EDC and analog. First question from network, this is of 1 marks. Here we have one dependent source, that is 1000 I naught. We have to take care of that alpha I naught, because the unit of alpha is not given, and that's why I am taking it what I naught as ampere, right? I naught in ampere I will calculate, and finally we will get the Ix, that is in milliampere. Now here we are going to apply the KCL. 5 milliampere outgoing current is I naught. That's why this current will become 5 minus what? Remember, this is in milliampere, and that's why we can write it what? 5 into 10 raised to power minus 3 minus I naught. That is in ampere. That is in ampere. Now here this is 2 milliampere. It will become 5 minus 2 into 10 raised to power minus 3 minus what? I naught, and that is the value of Ix. Finally we are going to calculate this. Here we have to put the I naught in what? Ampere. Now watch this. You can write the KVL in this loop. Here we are going to apply the KVL from this point to this point. Okay, so we can write like this. This is the plus minus, and that's why this is because we are considering the current in ampere, that will become in ohm. So 1000 into I naught, then it will become minus 1000 into I naught, and then it will become plus 1000 into, this is the 5 minus 2, that is the 3 into 10 raised to power minus 3, 1000 into 10 raised to power minus 3 minus I naught. That is multiplied here. This is multiplied here. Okay. Now is equal to what? 0. Now it will become very easy. 1000, 1000, 1000. You can take it what common. Then it will become minus I naught minus 2 I naught. Then open the bracket, plus 3 into 1000, because already we have taken the 1000 as a common, so it will become 3 into 10 raised to power minus 3, and then minus I naught. is equal to 0, and you will get I naught is equal to 3 into 10 raised to power minus 3 divided by 3, that is 1 into 10 raised to power minus 3 ampere. What is this? 1 milli ampere, right? Now what is the Ix here? Ix is 5 minus 2, that is a 3 into 10 raised to power minus 3 minus I naught, means what? If you are putting it in what? 3 into 10 raised to power minus 3 ampere minus 1 into 10 raised to power minus 3. So it will become 2 into 10 raised to power minus 3 ampere, means 2 ampere. That is the answer. 2 milliampere is the answer for this question. So why we have to take this? That is a very easy question, but be careful about what this 1000 I naught, because alpha, unit of alpha is not given, and the voltage in volt, current is in ampere, registers in ohm. Okay, or directly you can solve this question. The answer for this question is 2 milliampere, guys. Then second question is, in the circuit given below, the switch S was kept open for a sufficient long time. This is the question from the transient. It is of 1 marks. Closed at time t equal to 0. The time constant of the circuit for t greater than 0. What is the time constant for t greater than 0? Now here the switch is closed. Okay, when the switch is closed, when we have to calculate the time constant, first of all take the current source as an open circuit, make it 0. Then time constant for LR circuit is L by R equivalent. L by R equivalent. Now remove this 3H and find the Thevenin's resistance across this 3H. This is 4, this is 4, this is 2, and this is the terminal A, B. You can remove this inductor A and B. Then it will become 2, this is the 4 parallel with 4, it is 2, 2 into series, so that is the R equivalent is 4, it is 3, that is the 3 by 4, that is 0.75 seconds. This is the time constant. Okay, so this is the L by RTH or L by R equivalent. You have to find the Thevenin's across the inductor. Okay, so that is the time constant, and answer for this question is 0.75. Then next one, in the network shown below, maximum power is to be transferred to the load RL, the value of RL. Where is the RL? This is the RL, right? You have to find the RL, means maximum power transfer theorem. As you know, the value of RL is nothing but RTH. Value of RL is RTH, because we have to convert this circuit into VTH and RTH. VTH and RTH, and then what is the value of RL? It should be equal to what? RTH. Then guys, to find the RTH, because there is a dependent source, so what we are doing, first of all, we will remove this, right? 50 volt source, make it short circuit, and then this will become short circuited. Remove RL. Remove RL, or in place of RL, connect a 1 volt battery here. Let this current is I. Now guys, watch carefully. This is the 3 ohm, 2 ohm. This is the 2 ohm. What is this? Vx. It is also Vx. So Vx 2 ohm. Vx 2 ohm. And that's why this current is divided into 2 parts, exactly equal to, because these 2 parts have the same elements. So I by 2, I by 2. Now what is the value of the Vx? 3 into I by 2. Vx is equal to 3 into I by 2. Now we can write a KVL in this loop. So when I am writing the KVL in this loop, it will become 1 is equal to, this 1 is equal to 2 times of I by 2 plus Vx. And what is the Vx? 3I by 2. 3I by 2. Now you can take common I, 1 by I, that is nothing but RTH. 1 by I is what? RTH. How to calculate the RTH? 1 by I. Then this will become 2 by 2, that is what? 1 plus 1.5, that is 2.5. Answer for this question is 2.5 ohm, guys. So this is the 2.5 ohm. Then next one. Next question, again from the network theory. For the 2-port network shown below, the value of Y21 parameter is. What is the Y21 parameter? Y21 parameter, so first of all, remember you have to write the Y parameter. So that is the I1 is equal to Y11 V1 plus Y12 V2. and I2 is equal to Y21 V1 plus Y22 V2. So what is the Y21? Y21 is I2 upon V1 with V2 is equal to what? 0. Means you have to make what? V2 0 means short circuit parameter. So first of all, make it what? Short circuit. Make it what? Short circuit. Okay. Once you are going to make it what? Short circuit, then V2 will become 0. And now we have to calculate what? I2 upon V1. Where is the I2? This is the I2 upon what? V1. Okay. So can we write this is the I1? This will become I1 plus I2. In this loop, the current is I1 plus I2. So you can write a KVL here. It will become V1 is equal to 2 times of 2 plus 4, 6 times of I1 plus 4 times of I2 minus 8 times of V1. Okay, this will become 9 times of V1 is equal to 6 times of I1 plus 4 times of I2. You have to calculate I2 upon V1. So which one is the villain? 6 I1. Now write a KVL. You can write a KVL in this loop. Here you will get the relation between this. So it will become 4 times of I1 plus I2. Because what is the current in this branch? 4 I1 plus I2 minus 8 I1. 8 V1. Minus 8 V1 is equal to what? 0. Now from this you will get the relation I1 plus I2 is equal to 8 V1 divided by 4, that is the 2 V1. So I1 plus I2 is there, right? Now, or you can find I1 is equal to what? 2 V1 minus I2. 2 V1 minus I2 you can put here in this equation. So it will become 9 V1 is equal to 2 V1 minus I2 plus 4 I2. Okay, this is here 9 minus 2, that is the 7 V1 is equal to, this is what? 3 I2. 3 I2. Now what is the V1? I2 by V1. I2 by V1, that is the value of Y21. So Y21 I2 by V1, that will become 7 by 3. What is the 7 by 3? 1.75. Please check this. What is the 7 by 3? What is the 7 by 3 guys? तो क्या ये आंसर आ रहा है क्या? कैलकुलेशन जरा चेक कर लेंगे. ओके, दिस इज द I2 by V1 we have to calculate ना. I2 by V1 we have to calculate. ओके, ये देखिए यहाँ हो जाती है जैसे सिली मिस्टेक्स. चलिए इसको, ये 6 भी तो मल्टीप्लाई करना है 6 टाइम्स ऑफ I1, कोई बात नहीं. 9 V1 is equal to 6 times of 2 V1 minus I2 plus 4 I2. Right, then it will become 9 V1 is equal to 12 V1 minus 6 I2 plus 4 I2. Now guys, that side, this side, it will become 2 I2 is equal to 3 V1. Okay, so what is the I2 by V1? I2 by V1 is nothing but Y21, that is equal to 3 by 2, and answer is what? 1.5 Siemens. 1.5 Siemens. Okay, so what is the asked here? What is the Y21 in Siemens? Y21. So 1.5 is the answer for this question guys. Easy. So ऐसा बनाना था. Next one is, now this is the question from what? Analog guys. Network is over. Now we are going to solve some questions from analog, and that is the question on what? Watch this question carefully. Here it is actually a differential amplifier type circuit, but here feedback is applied here, and this is a current mirror circuit. This is what? Current mirror circuit. It will provide a constant current here. Now this is a V out, this is a feedback, right? There is 100% feedback, and that's why the beta factor for this is what? 1. So in this question, for a closed loop amplifier circuit, because there is a feedback, the magnitude of open loop low frequency small signal voltage gain is 40. Open loop gain is 40. All the transistors are biased in saturation. Remember, MOSFET works in what? Saturation. When we want to design what? Amplifiers. Then IAS is ideal, this current source is ideal. Neglect the body effect, channel length modulation and intrinsic device capacitances, the closed loop low frequency small signal voltage gain. What is the V out by V in? When we want to find a V out by V in, remember guys, there is a concept of feedback, and the gain of the system is given by feedback A upon 1 plus beta A. So what is the open loop gain? 40. What is the beta? Here this voltage will oppose V in, right? This voltage, if suppose there is a no feedback, then what is the voltage at this point? 0. But when there is a V out, this V out will oppose that V in, and that's why beta factor is 1. So you can write 1 plus 40. So 40 divided by 41, that is the answer for this question. Then this will become 0.976. 0.976. This is a differential amplifier and with feedback, and feedback factor is what? 1 here, right? In this way we can solve this question. Then here in this question, again this is a question from what? MOSFET. So this time number of questions from MOSFET. So first of all, in the circuit below, assume that the long channel NMOS transistor is biased in saturation and the small signal transconductance of the transistor is GM. Neglect the body effect, channel length modulation and intrinsic device capacitance, the small signal input impedance. You have to find the impedance, right? Now, once you want to find the impedance, then what is the small signal model for this MOSFET? Then small signal model for this MOSFET is, this is the GM-VGS, because channel length modulation is negligible, and that's why no need to consider the RD. This is the drain, this is the source terminal, and this is the gate terminal, right? Now from source to ground one capacitor is connected, like this is replaced by 1 by SC1, 1 by SCL, this is CL to SL. Now from gate to source, gate, this is the gate terminal, to source, one C1 is connected. To gate to source you can connect 1 by SC1. Let this is the, this voltage is VGS. Okay. Then from gate, this is the gate terminal. Now if you want to find the Z in here, consider a voltage here V, and let this is the current I. So Z in is nothing but V by I. Z in is nothing but V by I with respect to ground. This is the gate terminal. Now guys, remember this is open circuit, so this current will flow like this. This is the I, and then what is the current here? GM-VGS, and here current is I plus GM-VGS. I plus GM-VGS. I think now model is clear to you. So this is the 1 by SC1, this is the current. First of all, if you want to find the V by I, we can write the KVL from this point to this point. KVL from this side to this side. Okay, but there is one problem. What is the value of the VGS? Then to find the value of VGS, write down the KVL in this loop. When I am writing the KVL in this loop, it will become VGS, right, minus 1 by SC1 into I is equal to 0. So what is the VGS is equal to I upon SC1. Now you can write a KVL in this loop. It will become V is equal to 1 by SC1 I plus 1 by SCL I plus GM VGS. I plus what? GM VGS, guys. Now you can replace the VGS by I by SC1. So on the next page, 1 minute, give me. Okay, here. Now this is V. So you can replace 1 by SC1I plus 1 by SL into I, SCL into I plus GM upon SCL, and this VGS is replaced by I by SC1. I by SC1. Now it will become Z in. What is the Z in? V by I. Now it is 1 by SC1 plus 1 by SCL plus GM upon S square CL C1. S square CL C1. Now you can replace the S by what? J omega. When I am replacing the S by J omega, you will get, guys, 1 minute. Z in is equal to 1 by J omega C1. This S is replaced by then 1 by J omega CL plus minus, because J square is minus, GM upon omega square C1 CL. C1 CL, and that is the answer for this question, guys. So which answer is correct here? Which answer is correct here? This one. B. Minus GM upon C1 CL omega square plus 1 by J omega C1 plus 1 by J omega CL. Means you have to draw the small signal model in this question. Next one. Next question. Yes. Now that is a question on what we can say from this is a center tapped transformer type rectifier, full wave rectifier, guys. So this is the center tap, N/1 is given. In the circuit shown, the N/1 step down transformer and the diodes are ideal. The diodes have no voltage drop in the forward bias condition. If the input voltage is 10 sin omega t, this is the input voltage, 10 sin omega t, then the average value of the load voltage is 2.5 pi. Here, load voltage means the voltage across the RL. The value of N is, remember, guys, in a center tapped transformer type, this is the VM, this is the VM. So what is the total voltage from this point to this point? 2 VM. Or it is a step down transformer, and let this peak voltage is VP. So you can write the VP by 2 VM. VP by 2 VM is equal to N by 1 and N1 by N2, so that is the N by 1. So what is the N? N is nothing but VP by 2 VM. VP is the peak value on the primary side, that is the 10. This is the VP sin omega t. Now, so what is the value of 2 VM? Since what is the DC is given? DC is given as 2.5. DC is given as 2.5 by pi. And what is the DC value for the full wave rectifier? 2 VM by pi. So what is the 2 VM by pi? 2.5 pi. Pi cancel. You can say 2 VM is equal to 2.5. Now you can put here 2.5. So when I am putting the VP is 10 divided by 2.5, and you will get the answer 4. Answer for this question is what? 4. Be careful about that. This is what? 2 VM, total coil. N/1 means what is the voltage? VM center tapping, that's why the voltage at this point is VM, voltage at this point is also VM. Now, next one. Next question is, okay. As shown in the circuit, again from the analog, 1 mark question. As shown in the circuit, the initial voltage across the capacitor is 10 volt. Where is the capacitor? This is the capacitor. With the switch being open, the switch is then closed at t equal to 0. The total energy dissipated in the ideal Zener diode, 5 volt, after the switch is closed in millijoule. Means simply you have to find the power dissipation across the Zener diode. So what is the power dissipation across the Zener diode? Vz into I. So what is the energy dissipation? Energy dissipation means we have to integrate it. We have to integrate from what that is the switch is closed, rounded off to after the switch is closed. What is the energy dissipated? So energy dissipated means Pz, right, dt. And what is the time? 0 to infinity, right? So that is the case. So it is given. So how we can find what is the value of the current here, guys? Now watch this diagram. Now, what is the initial voltage across the capacitor? 10 volt. When the switch will closed, when the switch is closed after t greater than 0, the capacitor will discharge. Capacitor will discharge. But remember, the breakdown voltage for the Zener diode is 5 volt. Means once the Zener diode is in breakdown, then it will allow the current. Once it is out of breakdown, it will act as open circuit. So what is the minimum voltage required here? 5 volt. And that's why the capacitor will discharge up to what? 5 volt. Means exactly at t equal to infinite. What is the condition here? When the voltage across the capacitor is 5 volt, then now this Zener diode will not allow the current. Will not allow the current, guys. Therefore, remember, and current will become 0. Because this is the 5 volt. This is the 5 volt, 5 minus 5, it will become 0. So what is the initial value of the current? I0. 10 minus 5 by 10, 10 minus 5 by 10, that is equal to 0.5 milliampere. What is the final value of the current? 0. What is the time constant of the circuit? 10 kilo ohm into a 10 microfarad. 10 into 10 raised to power minus 6. Watch this. This is the 10 raised to power minus 3 and that will become 10 kilo. Sorry, this is the plus. And that's why this is the 10 to the power 5. That will become 0.1 second. Time constant is 0.1 second. From this information, you can find the current. I final minus I final minus I initial e raised to power t by tau. What is I final? 0 minus 0 minus 0.5 milliampere. Remember, this is in milliampere. E raised to power minus t by 0.1. And now you can write I is equal to 0.5 into 10 raised to power minus 3 e raised to power minus 10t ampere. This is the value of the current. Okay. Now, what is the power dissipation? Watch this. This is the power energy dissipation Pz into dt. So you can write energy is equal to integration from 0 to infinite. What is the Vz? Vz is 5. It is given. What is the Iz? Iz we have calculated 0.5 into 10 raised to power minus 3 e raised to power minus 10t dt. Integrate it, you will get, this is the 2.5 into 10 raised to power minus 3. What is the integration of this? E raised to power minus 10t divided by minus 10, 0 to infinite. When, watch this, this will become 0.25 into 10 raised to power minus 3. This infinity will become 0 and 0 will become minus 1. So this is the minus 1 minus, this is the minus sign. Minus minus it will become plus. And you will get 0.25 into 10 raised to power minus 3 joule. What is this? 0.250 millijoule. 250 millijoule. The answer for this question is 0.250 millijoule, guys. Right? So that is the question. Be careful about the units and so on. The answer is asked in what? Millijoule. 3 decimal places in millijoule and that's why answer is 0.250. यहाँ पर ना बहुत silly mistakes हुई हैं, बच्चों की वो ध्यान रखिएगा. Now next question is analog circuit. Again, this is of 2 marks. The operational amplifier in the circuit shown are ideal, but have the saturation voltage of plus minus 10 volt. Assume that the initial inductor current is of 0. It is visible. 0. The input voltage is triangular signal with peak voltage of 2 volt and the time period of 8 microsecond. Which one of the following statement is true, guys? Which of the following statement is true regarding this question? चलिए इसको बनाते हैं जरा. अब देखो, this is given op-amp 10 plus 10 supply voltage is given 100 and this is a symmetric trigger circuit, guys, because here it is a Vi is given. Standard symmetric trigger circuit. This is the 10 kilo ohm. This is normally called as R1. This is called R2, right? And for R1 and R2, for this particular circuit, the upper threshold level, because in symmetric trigger we are having the 2 level, upper threshold and lower threshold level. Upper threshold level is given by R1 by R2. R1 by R2 into what? V set. Into what? V set, guys. And then lower threshold voltage is given by that value. Okay. तो यहां से अब हमको क्या निकालना है कि एक्चुअली व्हाट वी आर गेटिंग हियर. तो देखो क्या क्या आंसर, पहले तो आंसर देखो. V01 is delayed by 1 microsecond relative to Vi. V02 is trapezoidal waveform. So what is the second circuit? Second circuit, what is this one? Integrator or differentiator? when we are using the inductor here, actually it is an integrator. So basically what will happen, this one is a square wave converter, means sinusoidal waveform is converted into square wave. Where is the sinusoidal waveform is given? The input voltage is a triangular. Okay, no problem. If it is a triangular wave, again it is converted into a square wave. Because what is the purpose of the Schmitt trigger? Schmitt trigger will convert square wave sinusoidal waveform into square wave, triangular wave into what? Square wave, right? So that is the case. Now guys, remember the threshold voltage, how we can calculate the threshold voltage. First of all, we will focus on this diagram. First of all, we will focus on the first diagram, this one. Only focus on this one. Now this is a Schmitt trigger. Okay, right now, right, this is the R1, this is the R2. Okay, then for this is the VI is connected here. First of all, find the threshold voltage. Voltages. In my number of classes, I have given you the idea about the what is the threshold voltage. Lower voltage minus upper voltage, lower resistance upon upper resistance into V set, and VLTH will become R2 by R1 V set. So what is the R2? 10 divided by 100 into 10, that is equal to 1 volt. What is the lower threshold? Minus 10 into 10 divided by 100 minus 1. Upper threshold and lower threshold is plus 1 and minus 1. Now, once you have the upper threshold and lower threshold, then what is the triangular wave here? Triangular wave is given as plus minus 2 volt peak values, time period of 8 microsecond. We can draw the triangular wave like this. Okay, then this is the triangular wave. This is 2, this is 0, this is minus 2. Okay, then what are the upper threshold and lower threshold level? 1 and what? 1. Okay, then what is about the square wave? मैंने zoom in किया जो थोड़ा सा देखना बनाना है. देखो, initially when the input is highly negative minus 2, output is minus 10. When it will cross the upper threshold, output will switch from minus 10 to plus 10. Again, when the input will decrease and when it will cross the lower threshold, then output will change. Again, when the input will cross the upper threshold, the output will change. Or in this way, we are getting the square wave. Now, what is asked here? What is the delay between the input and the square wave? V1. So, delay means what? It will cross the 0 at this point and it will cross the 0 at this point. So, what is the delay here? Now, delay you can calculate from this point to this point. Means you have to find the delay from this point to this point, because it will cross 0 here, it will cross 0 here. This is the one. Now, what's the triangular wave? What is the time period of the triangular wave? 8 microsecond. So, what is the time taken from this point to this point? That is the total change is 4. Total change is 4 microsecond. So, what is the slope of the line? Total change 4 volt from 2 to minus 2, and what is the time divided by 4, because half time is what? 4 microsecond, half time is 4 microsecond. Total time period is, it will become 1 volt per microsecond. 1 volt per microsecond, that is the slope. It will take 1 microsecond to change by 1 volt. So what is the change from this point to this point? 1 volt. And that's why what is the time taken by the signal to change by 1 volt? This is the 1 microsecond. Means the V1 is, this is the square wave is delayed by the triangular wave by 1 microsecond, because it will cross 0 here, it will cross 0 here. 1 microsecond delay. So you have to find the slope, and that's why you can say V01, this is the V1 or V01. This V01, the output of the first op-amp, is delayed by the Vi by 1 microsecond. Delayed by 1 microsecond relative to this statement is correct. Now V01 is not delayed, wrong. V0 is not delayed, wrong. V01 is delayed by the 2 microsecond, that is also wrong. So which answer is correct? Now no need to check the other point. No need to check the other point. V02 is a trapezoidal waveform. Now I am giving you the explanation why it is a trapezoidal waveform. Trapezoidal waveform means, guys, this is a, what is the peak value here? 10 and 10. 10, 0, minus 10. This is a integrator. This is a integrator. This is the L, this is the R. Then you can write the output of second one, V02, is given by minus, right? This is an integrator, so it will become R by this RF by L. RF by L. What is the R? 1 kilo ohm, L 1 millihenry. Remember, integral of input V01 dt. That is actually formula, because it is an integrator. Now guys, what is the value of R here? 1000. What is the L here? 1 millihenry. Integral of V01, remember this is a square wave. So for positive half you have to write the 10 dt, and for negative half you have to write the minus 10 dt. And what is the time duration? Time duration is from this point to this point. This is of 4 microsecond. Why? Because the time period of the input and time period of the output are same. It is a symmetrical triangular wave. That's why we are getting the symmetrical square wave. 4 microsecond, 4 microsecond. Now, when the input is 10 volt, it will remain 10 volt for 4 microsecond. When I am integrating from 0 to 4 microsecond and input is 10, remember guys, when I am going to integrate it, it will become 10 to the power 6 into 10 integral 0 to 4 microsecond of dt. Right? Now 10 raised to power minus 6 into 10 into what? 4 into 10 raised to power minus 6, because it is in microsecond. This is cancelled, plus 6. This is the plus 6. Plus 6 minus 6 cancel, and you are going to get the change of 40 volt. Change of 40 volt means we can get the 40 volt, but practically not possible. Why not possible? Because the highest voltage is 20 volt, and that's why it will saturate. That's why it will saturate. So we are not going to get the perfect triangular wave. So we are going to get what? Trapezoidal wave. Trapezoidal wave means like this, right? Because the variation is of 40 volt, but we are getting only what? 10 volt is the highest voltage, and that's why we are getting this type of waveform. This type of waveform here. This will move like this, saturate, move like this, saturate, and so on. Because if you want triangular wave, then like this. What is the total variation from this point to this point? That is of 40 volt. But we are getting only of what? Lowest value is minus 10, highest value is plus 10. The swing should be of 20 volt only. But we are getting swing of what? 40 volt, and that's why this is the trapezoidal. This is called what? Symmetrical clipping type circuit, guys. Okay? तो ये है इसका आंसर. तो A answer is correct one. Then अब आते हैं नेक्स्ट क्वेश्चन में. तो इज द करेक्ट आंसर. नाउ ये आया था दोस्तों एनालॉग सर्किट. दिस इज अ ऑपरेशनल एम्पलीफायर, right? And here this is a, we are connecting the signal here. Here we are giving the VF. When the VF will become VI, then when VF is exactly equal to VI according to Bar-Khosn criteria, this is an oscillator. This is an oscillator. Here the basic amplifier is what? Non-inverting operational amplifier. This is the basic amplifier. So what is the gain of the non-inverting amplifier? 1 plus RF. RF is R1 upon R1. So this is the R1 upon R. This is the gain of this basic amplifier, and that is what? Feedback factor. CR, high pass RC circuit followed by the low pass RC circuit. This is called feedback network. This is the gain A. This is the beta. And here, this is the Vi and this is the Vf. And this is the V0. So Vf upon V0 is beta, and according to Bar-Hussein criteria, mod of A beta is equal to 1. And what should be the total phase shift around the loop? Total phase shift around the loop should be multiple of what? 2 pi. 2n pi. If it is giving 0 degree phase shift, because it is a basic amplifier, 0 degree phase shift, then what should be the phase shift given by this? It should be also 0 degree or 360 degree. Then the Bar-Hussein criteria will satisfied. So you have to find the beta, that is the Vf by V0. So we just focus on this diagram. Focus on this diagram only. This is the V0 and that is the Vf. When we are focusing on this diagram only, CRRC, no, this is what is the voltage at this point? V0. You can replace by 1 by SC. This is 1 by SC. This is R. This is R. And voltage at this point is Vf. You have to find the Vf by V0. Guys, here you can use the mesh analysis I1 and I2. Then I2 Vf will become 1 by SC into I2. Now to find the IC, just write down the KVL here. When we are writing the KVL, V0 is equal to 1 by SC plus R into I1 minus I2 into R. That is the equation number 1. But remember, we have to find the I2. Now finally write down the KVL here. It will become I2 into 2R. This is the R plus R, 2R plus 1 by SC. Right? And then minus I into R is equal to what? 0. From this you can find the I1 is equal to I2 2R plus 1 by SC upon R. This is the I1. Now you can put this I1 into the equation number 1. You will get V0 is equal to 1 by SC plus R, and this will become 2R plus 1 by SC upon R. Right? This is the 1 by SC plus R into I2 minus I2 into R. I2 into R. Can you find the I2? Then I2 will become V0 into that R is multiplied V0 into R upon this will become 1 plus SCR upon SC. Okay. Then into 2R SC plus 1 upon SC. Please check my calculation. SC2 SCR plus 1. Then minus R square. Minus, this is the R is multiplied here, minus R square, guys. Right? And that R is gone upward. Then when we are multiplying, it is I2 is equal to, this is S square C square R into V0 upon, when it is multiplied here, it will become 1 plus SCR plus 2 SCR plus 2 times of R square C square S square minus R square. Right? Okay then, guys, now this is the I2. So what is the Vf? ISC into what? I2. ISC into I2. Then you can find Vf is equal to ISC into I2. 1 by ISC into I2. So this SC is cancel out. It will become SCR V0 upon, right? Then here you will get 1 plus 3 SCR, right? This is the 3 SCR plus 2 times of R square C square S square minus R square. ओके तो चलिए थोड़ा सा डायमेंशन भी चेक करते चले, कहीं कोई प्रॉब्लम ना हो जाए. ओके, लास्ट वन, दिस SC is multiplied here, it will become, because dimensionally everything should be fine here, because this SC is multiplied and it will go upward, so it will become 2 times of R square C square S square minus S square C square R square, S square C square R square, guys. It is subtracted here, then it will become, okay, finally VF will become SCR, VF by V naught, that is nothing but beta, upon 1 plus 3 SCR plus R square C square S square. Now guys, that is replaced by what? J omega. So you can write the beta is equal to J omega RC. S is replaced by that. It will become 1 plus 3 J omega RC minus omega square R square C square. Above numerator and denominator multiplied with the J. So it will become beta is equal to minus omega RC upon that J is multiplied to J 1 minus omega square R square C square minus, this will become 3 omega RC. Now guys, remember, imaginary part should be equal to 0 to satisfy the Bar-Hussein criteria, right? So when we are making the imaginary part is equal to 0, you will get the frequency of oscillation. Omega square R square C square is equal to 0, and what will be the omega? 1 by RC. This is called frequency of oscillation. And once we are making the beta 0, imaginary part 0, this omega RC cancel, you will get the beta is equal to 1 by 3. Beta is equal to 1 by 3. Then second condition, what should be the mod of A beta? That is equal to 1. So mod of A beta should be equal to 1. So what is the A is equal to 1 by beta? That is equal to what? 3. And what is A? 1 by R1 by R? That is equal to 3. So what is the R1 by R? That is equal to 2. So answer R1 by R is equal to 2. So which answer is correct? Answer for this question is R1 is equal to 2R and 1 by 2 pi RC. Because that omega is equal to 1 by RC, then what is the F? 1 by 2 pi RC. F is 1 by 2 pi RC, and that is the answer for this question, guys. So this is the standard circuit, standard answer. High pass RC followed by low pass, but that is the derivation, how to find the VF by V naught. Make the imaginary part 0 to satisfy the Bar-Hussein criteria. And from that you will get the frequency of oscillation. This is in radian per second. If you want in hertz, that should be divided by what? 2 pi. That is the answer. And then from that you can get the condition for oscillation. Remember, this is a non-inverting operational amplifier. Answer is A. Now next question, again from the analog circuit, MCQ, it is of 2 marks. MCQ, it is of 2 marks. Then one MOSFET is given here, one MOSFET is given here, one MOSFET is given, 2 MOSFET is given, one R and C. And in the circuit shown below, transistor M1 and M2 are biased in saturation. Amplifier banana hai, so it should be in saturation. Their small signal transconductance are GM1, GM2 respectively. Neglect the body effect, channel length modulation, intrinsic device, assuming that the capacitor C1 is short circuit. The exact magnitude you have to find, V out by V in. So answer is given. How we can find small signal model, guys? Small signal model. We have to draw the small signal model for this very easy question. But careful about that. So first of all, a small signal model for this diagram. This is, remember, this is the drain. GM1, VGS1. If both are identical, then both have the GM. If both are identical, they have GM1 and GM2. So this is a GM1 and that is the VGS1, remember. VGS1. So this is terminal is drain. We have to make it what? This current source open circuit for small signal analysis. So drain here, this is the source And then, but remember, if suppose you are considering, right, remember, you have to draw it properly. This is RB is connected. What about the second model? This is the GM2 VGS2. Channel and modulation negligible, and that's why you can remove what small RD. This is the drain of the second one. RD is connected here. This RD is connected. VDD you have to make it what, 0. This is the source. This source is connected to ground. For second one, this is connected to ground. This is the gate of the first one. Gate of the first one is connected to gate of the second one through the RB. Right? And the drain and gate are short circuited. So this is the D1, this is the G1. You can connect here. This is the G2, but there is a one resistor RB. Are you getting my point? This is the RB. This is the RB. Right? You can draw like this. Okay. Now this G2 is C1 and RS. This is the V in and RS is connected here. What about this source? This source is also connected to ground. This source is also connected to what? Ground. So you can draw it properly. This drain, right? Remember, this drain is connected to what? You can connect like this. This is connected to gate of that. Okay, first one. This is the RB. Be careful about that. This is R1, RB. This gate D2 is connected to C1. It will act as short circuit RS and V. RS and V in, guys, remember. Now, this voltage is called VGS2 and this voltage is called VGS1. VGS1 from this point to this point, and that is called what? GM1 VGS1. Okay, so I think now it is clear, because this will act as what? Open circuit. Remember guys, this will act as open circuit. Here any resistor RD. Now you have to take the output from here, V out. Guys, you can say the V out is equal to minus GM2 VGS2 into RD. Into RD. This is the, because opposite current will flow GM2 VGS2 into RD. Now you have to find the VGS2. So where is the VGS2? So you can write a KVL. Let this current is what is the current? This is the GM1 VGS1. Same current will flow from this point to this point. Right? Same current will flow from this point to this point. So you can write the, what is the current here? Minus this current is become minus GM1 VGS1. Right? So first of all, you can write a KVL, complete KVL from this point to this point. So what is the voltage here? Minus VGS1. This is the minus VGS1 plus RB plus RS into what? Minus GM1 VGS1 plus V in is equal to 0. Can you find a V in? What is the VGS1? Then VGS1 is equal to V in divided by, okay, V in divided by, because I am taking on the right hand side, this minus will become plus. It will become 1 plus GM1 RB plus RS. 1 plus GM1 into RB plus RS. This is the value of what? VGS1. This is the value of VGS1, guys. Now, you can write a KVL from this point to this point. From this point to this point. This is the VGS1. Now, find out the KVL. So, you can write minus VGS2 minus GM1 VGS1 R1 RS minus GM1 VGS1 RS plus Vin is equal to 0. Now, what is the VGS2? VGS2 will become Vin minus GM1 RS VGS1. What is the VGS1, guys? This is the VGS1, you can put here. VGS2 is equal to Vin minus GM1 RS Vin divided by 1 plus GM1 RB plus RS. Okay, now you can take the Vin. So what is the output voltage? Output is minus GM2 VGS2 into RD. So you have to replace the VGS2. So it will become V0 is equal to minus GM2 RD VGS2. So V in you can take common. It will become 1 minus GM1 upon 1 plus GM1 RB plus RS into V in. What is the V out by V in? Finally, V out by V in is equal to, now that will become minus GM2 RD to common hai, minus GM RD. Guys, when it is multiplied here, it will become 1 plus, right? That is the, but always remember you have to check that is the dimensionless or you are missing something. If you are, suppose you are missing, then it has become difficult to get the answer here. Yes, this is RS is missing here. This is RS. This GM1 RS, right? So you can write here 1 plus GM1 RB plus GM1 RS minus GM1 RS upon 1 plus GM1 RB plus RS. This is cancel out, and finally you will get GM2 RD 1 plus GM RB upon 1 plus GM1. This is also the GM1 RB plus RS. Now, just remember what is the answer here. When numerator and denominator is divided by GM1, it will become minus GM2 RD 1 RB plus 1 by GM1 upon 1 by GM1 plus RB plus RS. Since the magnitude is required, you can remove this. V out by V in, the magnitude is no need to consider the minus sign. So GM2 into RD, RB plus 1 by GM1, RB plus 1 by GM1 upon RB. This is the answer. 1 minute. This is the answer. D is the answer. GM2 into RD, RB plus 1 by GM1, RB plus RS plus 1 by GM1. What is the method here? Simply draw the small signal model, write down the KCL, get the VGS2 in terms of VGS1 and then finally VGS1 in terms of V in, and you will get the answer for this particular question. Okay. Now guys, that is, these all are the questions from what EDC. Now I will discuss questions from, these are the questions from what network and what analog. Now I am going to discuss questions from what EDC. Wait for it. Now question from electronic devices, that is MSQ 1 mark electronic devices. Now the free electron concentration profile in a doped semiconductor at equilibrium is shown in the figure. This is the figure here, and that is guys like this. This is the dash line. Okay, now it is visible. This is A point, this is B point, and that is C point. At this point, the concentration of electron is very high. When we are moving from B to C in X, this is the X between B and C. concentration decreases, again here the concentration decreases. For N type we are giving ND doping. For N type we are giving ND doping. ND means it will donate one electron and it will become what? Positive ion. It will become positive ion. Now, where the points A, B, C mark 3 different positions, which of the following statement is are true? So MSQ only 1 marks. Now watch this. For X between B and A, the electron drift current is directed from B to A. X between B and A, this is the B and A, the electron drift current is directed from B to A. Second option, from X to B, the electric field is. Third option, electron diffusion current. Fourth option, electric field. Means there is a in answer we are having 3 field. First electric field, second is what? Diffusion current, third is what? Drift current. Now one by one we will discuss. So what is this? Now watch this. Now, concentration at this point, like this is the graph. Concentration at this point is very high and at this point very low. Means, if this is the positive ion, because it will donate one electron, it will become positive ions. At this point, the doping concentration of ions is very, very high. Why? Because doping is high. This is the N is highest at this point. Again, this is the positive ions. Now, first of all, talk about the diffusion. Diffusion current, guys. When I am talking about the diffusion current, electron will diffuse from higher concentration to lower concentration. Means this is the point A, this is B, and that is C. So electron will diffuse from higher concentration to lower concentration. Means electron will diffuse from B to C. B to A and B to C. So what about the current? Because the charge of the electron is negative, the current will move in the opposite direction. Current will move in the opposite direction. That is the diffusion current. That is the diffusion current. Means when the point is between A and B, the direction of the diffusion current, or when the X is between A and B, direction of the diffusion current is from A to B, or when the X is between B to C, the direction is from C to B. Now what is the point here? For X between B and C, the electron diffusion current is directed from C to B. Between B and C, electron diffusion current directed from C to B. This means that is the correct answer. This is the correct answer. Now, what about the drift current? Now, between B and A, drift current. So, for drift current, electric field is required. So, what is the direction of the electric field here? Now, this area is more positive because it is a positive ions. With respect to that, that is the negative. With respect to that, this is negative, and electric field will direct it from this positive area to this negative area. Okay, so that is. So what is the direction of the electric field between A to B? It is directed from B to A when the X is between, or here it will direct it from B to C. So first of all, we will get the idea about the electric field. For X between B and C, the electric field is directed from B to C. That is correct. Yes, this is the direction of the electric field. Now, this means this is correct. Last point, watch this. For X between B and A, the electric field is directed from A to B. No, it is directed from B to A. Means what about this point? This is wrong. Okay, finally, for X between B and A, the electron drift current is directed from B to A. Now remember guys, electric field is in this direction, but what is the force on the electron? Minus QE. So electron will move from A to B under the influence of this electric field, right? Because that is the force, it is opposite to the direction. So electron will move in this direction. But what about the current? Electron is moving in this direction, but the charge of electron is negative. That's why the current is in this direction. This is the drift current. This is the drift current from B to A. So what is the direction here? For X between B to A, the electron drift current is directed from B to A. That is correct. The answer for this question is ABC. Answer for this question is A, B and what? C. Remember that. Now next question. Now guys, next one, that is from EDC. For non-degenerately means lightly doped. Means degenerately means what? Very heavily doped, just like what tunnel diode. And then Fermi level will lie inside the conduction band for N-type and inside the valence band for P-type. So non-degenerately doped N-type silicon, which one of the following plots represent the temperature dependence of free electron concentration N, free electron concentration N, guys. Now this is already in my class, already I have discussed this, right? Now remember guys, what is here? Temperature, but consider this, it is 1 by T. What is the meaning of the 1 by T? When temperature increases, 1 by T what decreases? 1 by T will decreases. So when we are moving from this point to this point, or we can say when 1 by T increases, what about the temperature? Temperature decreases. Okay. So now in this case what we are doing, because we have idea, when the temperature increases, new hole electron pair will generate, right? So suppose initially if it is N-type, if it is N-type, that this is the Fermi level, then what will happen? Initially it is N-type. First of all, this is the donor energy level, ED, and this is the donor, they will donate 1 electron. So when initially what will happen, when we are increasing the temperature, first of all they will donate electron, and that is called extrinsic excitation. Extrinsic excitation, and that's why the concentration of electron will increase. Finally 100% donor will donate the electron. For example, there are 1000 donor, so they will donate electron and finally it will reach to what? 1000. So after 1000 there is a saturation, because already 100% extrinsic excitation done. Now at the same time, we again, when we are increasing the temperature, after some time what will happen? Some electron will move from valence band to what? Conduction band, directly from valence band to what? Conduction band. That is called intrinsic excitation. That is called intrinsic excitation, from valence band to conduction band. It is no doubt when there is extrinsic, again there is an intrinsic, but in comparison to extrinsic, that is negligible, but it is continuously, it is moving. Then what will happen? After some time extrinsic will stop, 100% done, then intrinsic will slowly increases and it will bypass what? Extrinsic excitation, and now the extrinsic semiconductor is converted into what? Intrinsic semiconductor. So this is the actually graph. Watch this graph carefully. Now to 1 by T increases here, right? So what about the temperature? We are saying that 1 by T increases in this direction, right? So temperature will increase in this direction, because 1 by T increases means in this direction temperature decreases. So in opposite direction temperature will what? Increase. Remember, temperature will increase. So initially, what about the concentration? That is a log scale, no doubt. First of all, it is concentration increases because of extrinsic excitation, then it will become constant. At the same time there is a intrinsic excitation like this, but in this region extrinsic is more as compared to intrinsic, that will follow, and after that point intrinsic is greater than extrinsic, and it is converted into what? Intrinsic semiconductor. So this is the line shows intrinsic, and that is what? Extrinsic excitation. Extrinsic excitation. Okay, and that's why which one is the correct? So you can take the log scale, that is the log n, and this is the 1 by T. So this is the log n, this is the graph. So this portion represent extrinsic excitation, this is called saturation, and after that this is the intrinsic excitation. Okay, so that graph, answer for this question is already in my class I have discussed, right? That is from the standard textbook. Now next question, Okay, this is again a theoretical question, guys. Which of the following statement is are true for a BJT with respect to its DC current gain beta? DC current gain beta. Read all the points carefully, right? Read all the points carefully. ये मैंने आपको समझा ही दिया. ये है. Now, this is about the BJT, guys, right? Okay, first of all, read. We are starting from that point. A higher value of beta will lead to lower value of collector to emitter breakdown voltage, right? Higher value of beta, collector to, why we are talking about the collector to emitter breakdown voltage? That is the VCE, right? That is the VCE. This is the breakdown voltage between collector and emitter. And you have read about the BVCEO. That is called breakdown voltages. This is the true point. More will be the value of alpha, more will be the value of the beta, and then breakdown voltages will be low. Beta will be lower when the BJT is in saturation region compared to when it is in active region. Again, that statement is correct, right? Third one, when we are moving towards the saturation, go through the graph. When we are moving towards the saturation, what about the value of the beta decreases? And when we are moving towards what? In active region, deep in active region, we are increasing the value of VC, alpha increases, beta increases. So means when we are moving towards the saturation, VC decreases, and that's why the beta value will lower. Now, under high level injection condition in forward active mode, beta will decrease with increase in the magnitude of the collector current. Again, that is correct, right? Now, first point, under low level injection, there is a difference between under high level injection and low level injection. High level injection means doping is very, very high. When we are decreasing the potential barrier, there is a high level injection. That is called minority carrier injection. Under low level injection condition in forward active mode, where the current at the emitter base junction is dominated by the recombination generation, beta will decrease with increase in the magnitude of collector current. That is wrong, right? तो ये opposite point है. तो which one is the correct? BCD. So this time, guys, read EDC carefully, right? Theory point as well as numerical. Now we are going to discuss next question, that is the 54. NAT 2 marks. Again, a non-degenerate n-type semiconductor has 5% neutral dopant atoms. Its Fermi level is located at 0.25 electron volt below the conduction band, and the donor energy level has the degeneracy of 2. Assuming the thermal voltage to be 20 millivolt, the difference between the EC and ED in electron volt rounded off to 2 decimal places. Okay, now first of all, watch this diagram, right? This is ED, this is EC, this is ED, and now here we are having the Fermi level, EF. Okay, EC minus EF, that is given 25 electron volt. That is given in the question. Yes, yes, yes. That is the 0.25 electron volt it is given. Okay. Now we have to find EC minus ED. Now guys, we have the formula for what? ED minus EF. What is the formula here? This is the donor energy level. Now when there is a when we are giving the doping, so what will happen? Normally we are considering the ideal condition 100% ionization, but in this question practical condition, that is out of 100 dopant, only the 95 excited, ionized, and remaining 5% is not ionized, means they are not going to donate one electron to the conduction band. So what is the formula for that? That is given by, that is not ionized, N is given by ND total doping upon 1 plus 1 by G e raised to power, this is ED minus EF, that depends upon the gap between that upon what? KT. Now guys, if suppose you have the ED minus EF or you have the EC minus EF, then you can find the EC minus ED. So what is the EC minus ED? That is given by EC minus EF minus what? ED minus EF. So we have this is the 20.25. minus ED minus V you have to find. You can find from this formula. So what is the N here? This is in percentage. So this will become N by ND. N by ND into 100%, that is given as 0.5%. So this will become 0.05. 1 upon, this is 1 plus degeneracy is given as 2. E raised to power, we can find the ED minus EF upon, this is given as 20 millivolt, means 10 to the power minus 23. So you can find the KT from that. Now this is 0.05. That is equal to 1 upon 1 plus 1 by 2 e raised to power ED minus EF by 20 into 10 raised to power minus 3. Now what you can do, you can find the value of the ED minus EF. So this will become 1 plus 1 by 2 e raised to power ED minus EF by KT is equal to 1 upon 0.05, that is nothing but 20, that will become 19, and that will become 2 into 19, 38, and you can put the log here. It will become ED minus EF is equal to KT log of, remember that formula, and that will become 38. This is the natural log, and what is this? 20 into 10 raised to power minus 3 log of 38. You can find the ED minus EF. That was the question. Now, so this is the natural log 38 into 20 raised to power minus 3, and you will get 0.07275 electron volt, because it is ED minus EF. Now, what is the EC minus ED? 0.25 minus 0.072575. So you can subtract and you will get answer 0.177. That is given electron volt. That is given in electron volt. 1.18 nearly equal to. So the range is given actually. Range it is given 0.17 to 0.19. That is the answer key. 0.17 to 19. That is the answer. Now, remember, now next question on what? Solar cell. This time new question. Normally formula based, but this time the photo current of a PN junction diode solar cell is 1 milliampere. Photo current, for example, this is the diode, right? PN. Here we are giving the radiation. We are using the resistor here. Now what will happen? There will be the photo current from N side to P side. This is called IL. This IL will develop a voltage V, and that will make the junction forward bias. And because of that, in opposite direction, one current will flow, that is called IF. That is called forward bias diode current. So what is the resultant current? IL is always greater than what IF. So what is the I? I will become IL minus IF. IL minus, what is the IF? Forward bias current, reverse saturation current, e raised to power V upon Vt minus 1. That is the formula for I. So this is IL is called photo current, I naught is called reverse saturation current, V is called the voltage across that, and Vt. Now what is given here? Photo current of PN junction 1 milliampere, it is given the voltage corresponding to its maximum power point. Maximum power point is 0.3. So when we are getting a maximum power output, that is called Vm into Im. Vm into Im. How we can get the maximum power output? I will give you the idea. If the thermal voltage is 30, that is the Vt is 30. This Vt is given 30 millivolt. Reverse saturation current you have to find I naught. This is a good question. Now, what is the power output? It is simply given by V into I. What is the power output across the resistor? V into I, because the resultant current is I. So V into I, that is the power output from this resistor. When it will be maximum, when V is variable, because so we can put the value V I in terms of what? V IL plus, because IL is constant, I naught e raised to power V by Vt minus 1. Right? Now what we can do, we can differentiate with respect to V, dP by dV, because it is a variable. It will become differentiation. First we will differentiate it, so you will get the IL plus I naught e raised to power V by Vt minus 1 plus, now V differentiation of this. So what is the differentiation? This is constant, it will become 0. Here you are going to get the I naught upon Vt. This is the 1 by Vt, that will become I naught e raised to power V by Vt. And what is the differentiation of 1? That is what? 0. Okay, so please check my calculation. Now guys, for maximum you have to equate it to what? 0. Right? Equate it to 0. So it will become IL plus I naught e raised to power V by Vt minus I naught, be careful about that, plus I naught V by Vt e raised to power V by Vt. Okay, we have to find I naught and we have the value of IL. Now on the right, and equate it to what? 0. Equate it to 0. So it will become I naught, you can take common, then or what, e raised to power V by Vt, again you can take common, then it will become, from this you will get the, on the 1 minus something, na? Please check. Okay, 1 minute, give me 1 minute. Everything is fine, I have differentiated it. And then, okay. Now, when I am taking this as a common, it will become 1 plus V by Vt, 1 plus V by Vt minus 1. Right? And that is what? Plus IL. Okay, तो check. ये हो गया आपका करंट गाइस. राइट, हाँ यहाँ पर देखिए माइनस साइन ना, दिस इज द आई इज इक्वल टू व्हाट? माइनस एक्चुअली. This is minus IL minus IF. This is the IL minus IF. You have to use the minus sign, and that's why when I am differentiating, it is the minus sign. Right? This is the IL minus. This is the differentiation, and here again when I am differentiating, this will become what? This is the 0, and that will become minus sign. Okay, no problem. Now this is minus, and that's why it is minus. Right? And this is also minus. Right, or this minus it will become plus. Okay, now on when I am taking on the right hand side, this will become plus, and that on the right hand side it will become plus. You can find the value of I naught from that. It will become I naught is equal to IL. Remember now this formula, e raised to power V by Vt into 1 plus V by Vt plus minus 1 guys. Now I naught, this is 1 milliampere, e raised to power V by Vt. What is the V applied? Maximum for maximum power, that Vm is given. What is the Vm is given? Maximum is 0.3, maximum that is given 0.3 volt. So it will become 0.3 upon, this is the 30 millivolt, 0.03. It will become e raised to power 10. 1 plus 0.3 upon 0.03. Again it will become 10 minus 1. So what is the I naught? 1 upon e raised to power 10 into 11 minus 1. That 1 is negligible as compared to that. And this is the 1 milliampere. Now you can find the value. You can find the value for this. (4.12 into 10 raised to power minus 6). 4.12 into 10 raised to power minus 6 milliampere, because one is, it is the IL is in milliampere, and that's why it is called 4.12 nanoampere. 4.12 nanoampere. Answer for this question is 4.12 nanoampere. Okay, so that is the question. तो थोड़ा सा लेंदी है, but लेकिन it is of 2 marks. 4.12, that is in range from this point to this point, guys. Okay, next question. Consider a MOS capacitor made with a p-type silicon. It has oxide thickness of 100 nanometer. Oxide thickness of 100 nanometer and a fixed positive oxide charge of 10 raised to power minus 8. This is called oxide charge at the oxide silicon interface, and the metal work function of 4.6 electron volt. Assume that the relative permittivity of oxide is 4 epsilon r epsilon naught, that is the epsilon or epsilon naught, that is the equal to 4 epsilon naught. And what is the value of the epsilon naught? It is 8.85 into 10 raised to the power minus 14. If the flat band voltage is 0 volt, the work function of the p-type silicon, what is the p-type silicon work function is? So guys, this is a very standard formula. What is the work function? Flat band voltage. Flat band voltage is given by phi ms minus charge upon COX. Charge trapped that in the interface of the oxide and semiconductor, and that is a per unit area. This is also per unit area. So phi ms, this is given as 0. Phi m minus phi s, you have to find the phi s, minus what is the charge trapped, it is given 10 raised to the power minus 8 upon COX. You have to find the COX, oxide capacitance, that is given by epsilon r epsilon naught upon TOX. Epsilon r 4 into 8.85 into 10 raised to the power minus 14 upon TOX, that is given as 100 nanometer. 100 nanometer, you can convert it into centimeter, 10 raised to the power minus 7, right? That is, so this is the value. So you can find the COX. This is the 10 raised to the power minus 5. It will become what? 10 raised to the power into 8.85 into 10 raised to the power. This is minus 5 minus 9. Now you can put this value here. This is 0. What is the phi s? Phi s will become phi m minus 10 to the power minus 8 upon COX. What is the phi m? It is given. Phi m metal work function 4.6. minus 10 to the power minus 8 upon this value, 4 into 8.85 into 10 raised to the power minus 9. That will become 10 upon something. Or this is 10 divided by 4, it is a 2.5. 2.5 upon 8.85. Make the calculation as easy as possible. Now directly you can calculate it. 2.5 divided by 8.85. Right, minus 4.6, and guys you will get 4.31, right? That is the work function, 4.31 electron volt, guys. The answer for this question is 4.10 to 4.50. That is the range. 4.31 between this. This is the formula based question on flat band voltage. So flat band voltage already in previous year questions we have the question on what flat band. This is the in 2024. Now again the question on what NMOS transistor. So what is the question here? NMOS transistor, right? So we have again one more question after that. So this is a NMOS transistor operating in the linear region. Operating in the linear region. So we have like what, this is the curve. When we are talking, this is the linear ohmic region, then it will enter into the saturation, right? In this region, as you know, VDS is less than VGS minus VT, or in this region VDS is greater than or equal to VGS minus VT. That is called saturation, and that is called linear ohmic region for very, very small value of VDS. And what is the value of the VDS? It is very small, 0.1, that is given. Linear ohmic region 5 microampere, that is given. Keeping the VGS constant, VDS is increased to what? 1.5 volt. This is a very high value. So mu and COX, it is given. Transconductance at the new operating point, GM you have to calculate. First of all, in linear ohmic region, what is the formula for the current? K and S, that is the mu and COX. K and S is nothing but mu and COX. W by L. VGS minus VT into VDS minus half of VDS square. We are assuming that is a linear ohmic region. So this current is given as 5 microampere. This is given as 50. It is given mu and COX W by L 50. This is micro, this is micro. From this you can find the value of VGS minus VT because threshold voltage is not given. This is given as 0.1 minus 0.1 square upon what? 2. You have to consider everything now. Then guys, this will become 0.1 right? Now this is become 0.1 square divided by 2, right? And again that is divided by what? 0.1, and that is the value of what? VGS minus VT. Okay, so now tell me what is the value. So 0.1 square of that, be careful now, 1 by 100 divided by 2 plus 0.1 divided by 0.1, you will get 21.05. 1.05, this is the value of VGS minus VT. Now guys, VDS is increased to what? 1.5. 1.5 is greater than what? VGS minus VT, means definitely it is in what? Which region? Saturation. Or when we have find the VGS minus, it is proved it is in what? Linear ohmic region, we have assumed, because what is the value of the VD initially? 0.1. This is less than what? VGS minus VT. Means suppose if you are confused, then again we have proved it is in linear ohmic region initially, but it is what? 0.1, because it is less than that. But now it is greater than that. By keeping the VGS constant, means it is in saturation region. What is the formula for saturation region? Half of mu n COX W by L VGS minus VT the whole square. Now what is the half of 50? This is the 50 microampere. Remember, what is the VGS minus VT? 1.05. But what is current is not required. Sorry, current is not GM. What is the trans conductance, guys? Mu n COX, that is the K and X, W by L, VGS minus VT only. Because what is the GM? DIDS by VGS. dVGS. When we are differentiating, you will get this. This is given as 50 into 1.05. 50 into 1.05. That is what? 52.5 microampere per volt square, per volt. Microampere per volt. It is required microampere per. Easy. यह है इसका आंसर. Range is given. Oh, range is what? 52.4 to what? 52.6. And answer is 52.5. Okay, so proper calculation is required in this question, guys. Okay, next one. Okay, that is the, I think, 1 minute. This is the last question, guys. Okay, finish. Now, sir will take what? Communication. This is all from my side, from network, from what? EDC, and from what? Analog, guys. Try to solve all this question and don't try to mug up. Get the command over the concepts of this question. Thank you.
Hello, so now we are going to solve the questions of the GATE 2024 from the subject communication system. So let's start with the first question of the communication, that is the question number 58. A source transmits symbols from an alphabet size 16, the value of maximum achievable entropy in bits. So this is a numerical answer type question and this is a 1 mark question. So what is the entropy when there is a 16 symbols are there? So there is no probability given. And what is the maximum entropy? So the range of the entropy, we know that this range of the entropy is from 0 to h of x, and this is log base 2 m, that is the number of symbols. So this is the range. So the minimum value of the entropy could be 0 and the maximum value can be log base 2m. So now, because it is asking for the maximum entropy, so the maximum entropy, we will say this would be log base 2 number of symbols, and the number of symbols are here 16. So the answer will be 4. So very simple question, 1 mark question. So the right answer for this question would be 4. Now coming to the next question. Suppose the x and y are independent and identically distributed random variable that are distributed uniformly in the interval 0 to 1, then the probability that x greater than y. Okay, so here there are two independent random variables. So the one important concept is used here, that suppose there are two independent random variable x and y, and if they are added together, okay, suppose they are added together here like this, and we get some another random variable, say x plus y, then the probability density function of z can be written as the convolution of x and y PDF. The PDF of x and y can be convolved to get the PDF of z if they are added together and they are independent and identical. So now you can think of that how we are going to use this concept in this question, right? So x greater than y is given. So can I write x minus y greater than equal to 0? This is equivalent to x greater than y. So I am assuming that the z is another random variable which is actually x minus y. So now I can say that we want to calculate z greater than 0. So now if I get the probability density function of z, then I can also calculate the probability of z greater than 0. Okay, our aim is to calculate probability of x minus y greater than equal to 0, and I am assuming that the z is equal to x minus y. That means I want to calculate probability of z greater than equal to 0. Now, to calculate the probability of z greater than 0, we need a probability density function of x and probability density function of minus y. Since the probability density function of x is given as 0 to 1, it is given as 0 to 1, and if I take the PDF of minus y, it will be folded version, correct? So this is fx of x 0 to 1. This is the PDF of x, and this is the PDF of minus y. So PDF of minus y, that doesn't mean that you have to take the value of PDF negative. The PDF of minus y means the value of the random variable become negative. So the value of the random variable is from 0 to 1. Now the value will be folded, that is minus 1 to 0. I am using the same variable x. Now what is the PDF of z? The PDF of z is, because this is the two rectangular pulse, so the PDF would be a triangular. The convolution of the two rectangular pulse is triangular, right? So this is the PDF of z. This is the PDF of z. The lowest value is minus 1, the highest value would be 0, mid value is 0, and highest value is 1. Now we want to calculate probability z greater than 0. So z greater than 0, this is the range where the z is greater than 0. So probability that z greater than equal to 0 is 1 by 2, because the total area under the PDF is 1. So it is symmetrical about origin. So it is 1 by 2, which is equal to 0.5. So the right answer for this would be 0.5. Very easy question. And I'm assuming that you know the basic concept of signal and how we get the convolution of the two PDF or two rectangular pulse is nothing but a triangular, that I'm assuming. Okay. So the height also we can calculate, because the slope of this PDF is nothing but the multiplication of the height of the two individual PDF. So the height is 1 here, 1 here. So the height is 1, the slope is also 1. So to make the slope 1, the height of this rectangular pulse should also be 1. So in this way, I can draw this diagram, and from the diagram, I want to calculate probability z greater than 0. What is the z greater than 0? That is the probability density function given. So the area under the probability density function gives the probability. Hence, we will calculate the area of this. So that is also 1 by 2, base height, that is also 0.5. Or also you can say that because it is symmetrical about origin and the total area under the PDF is 1, so half area would be 1 by 2. Now the next question is from the aptitude modulation. This is again a 1 mark question, and it is very basic question, and it is asking that an amplitude modulator has the output S of t A cos 400 pi t plus B cos 360 pi t plus B cos 440 pi t. The carrier power normalized to 1 ohm resistance is 50 watt. The 1 ohm resistance is 50 watt. The carrier power is 50 watt for 1 ohm resistance. The ratio of the total sideband power to the total power. Total sideband power to the total power is 1 by 9. The value of B rounded off up to the 2 decimal. So, for the single tone modulating signal, right? For single tone modulating signal, okay, for a single tone modulating signal, the expression for amplitude modulated signal is given as A cos, let me write in this form, A1 plus modulation index and then cos of omega mt and cos omega ct. And when you expand this, you will get A cos omega ct and A ma by 2 cos omega c plus omega mt and plus A ma by 2 cos omega c minus omega mt. So this is also the similar type of expression, and how you are getting this expression that I am telling you. So now if you compare this, you can easily see that there are two terms which are having the same amplitude, and these are nothing but the sidebands. And this is the term which is having the separate frequency is nothing but a carrier. So this term is our carrier in this question, and these two are the sideband. And we want to calculate the ratio of the total sideband power to the total power. Okay, so what is the total power? Let's say total sideband power. So total sideband power is nothing but the A MA, that is the modulation index. So here it is given as B, correct? The whole amplitude is given as B. So let me write in this form also. Once again, this expression I am writing this A cos 400 pi t plus B cos 360 pi t. This is our upper lower sideband, and then B cos 440 pi t is our lower sideband, upper and lower sideband. So now we want to calculate the sideband power. So sideband power is, these are the two terms which are sideband. So this is B square by 2 plus B square by 2, that means B square. So sideband power is B square. Now what about the total power? The total power is nothing but the carrier power, which is amplitude square divided by 2 plus sideband power, which is B square. And now it is given that this ratio, the ratio of the sideband power to the total power is 1 by 9. So now we will substitute our values B square upon A square by 2 plus B square equal to 1 by 9. Now we want to calculate the B. So what is the value of A square by 2? So this carrier power is also given as A square divided by 2 into resistance we given, normalized resistance is given, so that is R is 1 actually. So that is why this R is, we have already taken 1. This carrier power is given as 50. So A will become, or A square by 2 will become 50. Okay, you can directly write A square by 2 become 50. So we will substitute it here. So B square upon 50 plus B square equal to 1 by 9. Now we will solve it. This is 9B square equal to 50 plus B square, and it is 8B square is equal to 50. So B is equal to 50 by 8, or you can say this is 25 by 4 or 5 by 2, which is 2.5. Okay, that is 5 by 2, which is equal to 2.5. So the right answer will be 2.50 up to 2 decimal. So in this way you can solve this question. This is 1 mark question, so we should not spend so much time in this type of question. Okay, this is A square by 2, which is carrier power. You can directly substitute this A square by 2, which is 50, and then when you solve it, you will get your correct answer. Now this question is given as the MTA Okay, and this question is given as MTA, but the standard form, we can say that for the Nyquist, okay, suppose we want to derive it, then according to the Nyquist criteria, the pulse which should be, because this is given as xt, so let me write it xt, the pulse which is actually providing the 0 ISI is, according to the Nyquist, it is this pulse, which says that x of t should be equal to nt. It should be equal to 0 for t is equal to nt. Okay, for t is equal to nt, and here it is written m, so you can write m, where m is integer. That can be 0 plus minus 1 plus minus 2 and so on. This is the Nyquist criteria, Nyquist pulse, which we usually call it as Nyquist pulse. So this is t minus t, 2t minus 2t and so on. And the train of impulse, we know that the train of impulse is given as this 0, t minus t and so on. This is the train of impulse. So if I write it, this, if I suppose want to sample it x of t, because it is given in the discrete form, so if I sample it x of t with this train of impulse, this train of impulse can be written as n equal to, or m equal to minus infinity to infinity. Okay, and it can be written as 10t minus mt equal x of 0 only. When we multiply, we will get x of 0 and delta t. If I take the Fourier transform both sides, we will get 1 upon t summation m equal to minus infinite to infinite x of f minus m upon t, or we can write mfs, and fs is inverse 1 upon t. Okay, so we usually write like this, and also you can write plus here, because whether you put a plus or minus, it doesn't matter, but most of the time in these textbooks they write minus sign, so that is why maybe the reason that they have given as MTA, because if you see the textbook, they give the minus sign, and in all the options it is given as plus sign, so that may be the reason. And when you take the Fourier transform, you will get x of 0 and delta t has the Fourier transform 1, so you will get 1 over here. Okay, and when you solve it, just a second. Yes, so now we will solve it. So f plus m by t equals t, that is summation m equal to minus infinity to infinity. So according to this, we are getting our C option correct, na? But they have given as MTA. So this may be the proof of this question. But if we go through all this detail, there will be a detailed derivation can be there. But in all the textbook also, this is the proof which is given. So we can also apply this here. But as I told you that because of this minus sign, maybe somebody has posted it from the reference of any textbook, and they have accepted their challenge, and they have given marks to all the aspirants for this particular question. X of 0 is also 1. Na? At t equal to 0, this x of 0 is also 1, and delta t is having the Fourier transform 1. So that is why we are taking 1. Now, this is one more question. This is again 1 mark question. A white Gaussian noise Wt with the 0 mean and the power density is N0 by 2 when applied to a first order RC low pass filter. Okay, when applied to first order RC low pass filter, produce an output NT, then particular time t is equal to tk, the variance of the random variable NTK would be. So, because we are passing it through the low pass filter, so when we are passing through the low pass filter, the transfer function of the low pass filter is 1 upon 1 plus RC S, correct? And if you write in terms of omega, then it can be written as 1 by RC and 1 by RC plus J omega. Okay, we know that the mean of the output, let us say the output is Y, then the transfer function H of 0 multiplied with mean value of input. Since the input is white Gaussian noise which is having the 0 mean, irrespective of H of 0, the output will also have the 0 mean. We want to calculate the variance. So the variance is equal to the mean square value minus mean of output, and the mean of output is 0. This is 0. Hence the variance is nothing but the mean square value. So variance of output is nothing but the mean square value, or you can say that the output power. Okay. So output power we want to calculate. And how do you calculate the output power? The output power can be calculated by power spectral density of output. So H of omega mod square multiplied with Sx of omega, which is input power spectral density. Input power spectral density is noise, so which is given as N0 by 2. H of omega mod square we can calculate, and we also know that the area under power spectral density gives power of the process. So if I calculate the area of Sy of omega, I will be able to calculate the power of the process, and the power will become variance because the mean is 0. So now if I calculate the area under output power spectral density, okay, area under output power spectral density, so that is suppose Py, which is our actually variance, which is nothing but our variance, which is equal to 1 upon 2 pi integration from minus infinite to infinite Sy of omega d omega. So 1 upon 2 pi minus infinite to infinite H of omega mod square. So if I take the magnitude of this, then I will get 1 upon RC whole square. Okay, 1 upon RC whole square and 1 upon RC whole square plus omega square. This is mod whole square. Okay, mod and then whole square. So 1 upon RC whole square divided by 1 upon RC whole square plus omega square into N0 by 2 into d omega. Now, because it is even function, so we can write 1 by pi 0 to infinity 1 upon RC r square c square and 1 upon r square c square plus omega square multiplied with N0 by 2 d omega. So this is 1 upon pi, 1 upon a is your r and c. And tan inverse omega RC and it is 0 to infinity, and we have N0 by 2. Let me write it correctly. This is we have 1 upon r square c square outside this integration, and then 1 upon a is RC, right? So if I put this 1 upon RC will get cancelled, and we have N0 by 2 also, and tan inverse infinity minus tan inverse 0. So we will get N0 by RC into pi by 4. Okay, pi by 2 from here, and this 2 is already there. This pi and pi will get cancelled, and we will get N0 by 4 RC. So N0 by 4 RC will be the right answer, which is option number C. Okay, so this is how you can calculate. Now the next question is, again, this is a very good question. A source transmits a symbol S taken from -4, 0 and 4 with the equal probability. All are having the same probability, and the received noisy symbol S R is given as R is equal to S plus omega, where W is 0 mean Gaussian noise with the variance 4 and this is the Q function given, then optimum probability of error. So very simple, this is the maximum likelihood question because it has the equal probability. So we can call it as this is the maximum likelihood condition. How do you calculate the probability of error? So probability of transmitting -4 and probability of receiving signal when the -4 is transmitted. Similarly, probability of transmitting 0 and probability of error. Let me write it here. E, probability of error. Probability of error when -4 is transmitted, probability of error when 0 is transmitted, and a probability of 4 is transmitted, then probability of error when the 4 is transmitted. So the probability of all the symbol -4, 0 and 4 is given as 1/3 because they are equal probability. Now we want to calculate the P probability of error when -4 is transmitted. So what is the now if I want to draw, because this is the Gaussian noise, receive signal is, because the channel is Gaussian, so the receive signal is noisy. So to draw the PDF of the received signal, since R is equal to S plus W, and R is the receive signal and the W is 0 mean white noise with variance 4 and having the noisy channel. So this is Gaussian in nature. Because the W is Gaussian in nature, so the R will also be Gaussian. And because the R is Gaussian, we can write its probability density function. So probability density function of R can be written as 1 upon root over 2 pi variance of R and e to the power minus of R minus mean of R whole square divided by 2 into sigma square. So this is the PDF. What is the mean value of R when the -4 is transmitted? Okay. So when -4 is transmitted, the symbol -4 is transmitted, then in this case the R is equal to S plus W. -4 is transmitted means S is equal to -4. So R will become -4 plus W. So what is the mean value of R, which I have denoted as R bar? Expected value of -4 plus W and the expected value of -4 plus expected value of W. So expected value of constant is constant itself, so -4, and expected value of W is 0 because it is given that the W is having the 0 mean. So it is -4. Now what about the variance? So variance of R, that is sigma. So variance of -4 plus variance of W. So variance of -4, variance of constant is 0. Variance of W is given as 4. Yes, it is given as 4. So we have 4. So the variance sigma square is 4. Now variance is 4, that means sigma is 2. Okay. Now what is the PDF? So the PDF when the received signal, PDF of received signal when which is transmitted, -4 is transmitted, 1 upon root over 2 pi into sigma square, that is 4, e to the power minus R minus R bar. R bar is -4. So -4 whole square divided by 2 into sigma square, which is 4. So if you will draw the PDF, it is symmetrical about -4. Okay, and this will be the value 1 upon root over 2 pi into 4. So this is the PDF of received signal when -4 is transmitted. Similarly, in the same way, when you calculate for the 0, instead of this -4, you will get 0 everywhere. So this -4, that means you will get 0 here and you will get 0 here, and the rest of the things are same. Variance will remain same. So that means if the mean is 0, that means it will be center at 0. So now if I combine all the PDF, we will get like this. Okay, so let me draw. This is -4, this is 0, and this is 4. This is the received signal. So this is the probability density function of received signal when -4 is transmitted. This is the probability density function of received signal when 0 is transmitted. This is the probability density function of received signal when 4 is transmitted. And we know that because it is the maximum likelihood condition, all are having equal probability, the threshold value is calculated where the two PDF are intersect. So this PDF and this PDF are intersect at this place. So this is our threshold value and this is our threshold value. So what is this threshold value? This is the midpoint of -4 and 0. Okay, that is nothing but -4 plus 0 divided by 2, which is equal to -2. And this is 0 plus 4 divided by 2, because this is the midpoint of 0 and 4. So it is 2. So the threshold value is 2 and -2. Okay. Now, when you how do you calculate the error? So probability of receiving error when -4 is transmitted when the received signal is greater than -2. Okay, because in this region you will take decision in favor of -4 only. But when your received signal is greater than -2, then you will take decision in favor of either 0 or you may take the decision in favor of 4. It depends on the received signal. But the received signal when less than -2, you will definitely take the decision in favor of -4 because this is the PDF of -4. So in this region, you will get the correct data, but the error we want to calculate. So error will occur whenever the received signal is greater than the threshold value, which is -2. So we can write it as 1 minus probability that r less than equal to -2. So it can be written as 1 minus CDF of -2, and it is 1 minus f of -2 can also be written as f of 2. So it can be written as f of 2. So this is 1 minus q of 2 minus x bar, which is in this case -4, and divided by variance is 2. So we are getting 1 minus q of 3. 1 minus q of 3. 1 minus q of mean is -4. So x minus x bar. What is the PDF? The PDF is, if you want to write for the Gaussian random variable, then it is 1 minus q of x minus x bar divided by sigma. So x bar, this is -2, no? Okay, let me write in this way only. So 1 minus f of -2. So 1 minus in bracket 1 minus q of -2 -4 become +4 because the mean is -4, and it is sec 2, and we are getting 1 minus 1 is cancelled. So q of 4 minus 2 is 2. 2 divided by 2 is 1. So q of 1 we are getting. Q of 1. So here also you can see that in the two options we have q of 1 and in the two options we have q of 2. So definitely either A or B will be correct because we are getting q function as the 1. Q, in the argument of q function we are getting 1. So this is the way. This is the if you have the Gaussian random variable, then the CDF is given by this expression. So we can substitute it here. Similarly, probability of error when the transmitted bit is 0 is when you will get an error, you will receive the correct data when your received signal is in between these two thresholds. So -2 to 2. So it is 1 minus probability of received signal between -2 to 2. So 1 minus in bracket, it can be written as fx of 2 minus fx of -2. So 1 minus in bracket 1 minus q of 2 minus 0, because the mean is 0 in this case, 2, and minus of 1 minus q of minus 2 minus 0 divided by 2. So this is 1 minus in bracket 1 minus q of 1 minus 1 plus q of minus 1. So this 1 and minus 1 will get cancelled and we will get 1 plus q of 1 minus q of minus 1. So 1 minus q of 1 can be written as q of 1. So this is 2q of. Okay. So you remember that 1 minus q of minus x is also equal to q of x. So I am using for first and the last term this property and q of 1. Now I will calculate the probability of error for plus 4. So when you get the correct decision here, so in this region you will take the correct decision. So less than 4 you will get incorrect decision. So probability that received signal is less than plus 4. So it is already less than. So f of 4 we can write. So 1 minus q of 4 minus 4 mean is 4. The value is also 4. Mean is minus 4. Mean is 4. The value is also received signal less than 4 now. Less than 4. Less than 4. We are getting less than 4 only. The mean value will be received signal is 4 and mean is 0. So mean value is only 4 only. Mean value is 4 only. So 4 minus 4 is getting 0. Sigma x is 2. So in this case it is 0. 4 minus 1 minus q of 0 is 0.1 by 2. So 1 by 2. We are not getting q of 1 here. What is the wrong in this? Check once. Mean we are getting correct. Then why there is a mistake here? Mean is 0 minus 4. So for those two answers we are getting correct, but this one is having some calculation mistake. I think I had done less than 4 only, na? Oh, sorry. I have to take threshold value, na? In this also I have taken threshold, na? It should be less than threshold, not less than mean, na? So the threshold is 2. I'm sorry for this. Yeah. So probability of error when the symbol 4 is transmitted. So received signal should be less than the threshold value. Less than the threshold value. So threshold value is 2 here, not 4. 4 is the mean. So less than 2 here. So now we will get f of 2. And this is 1 minus q of x minus x bar. X is 2, x bar is mean is 4 divided by variance. Variance is 4, but we want to write sigma. So sigma is 2. Okay, so 1 minus q of minus 1. So again we will get q of 1. So you can see that all the values if I add, because the probability of all the symbols were same, so it was 1 by 3, and the probability of error when minus 4 was transmitted plus probability of error when 0 was transmitted plus probability of error when plus 4 is transmitted. So what we get in the first case, I think we have got q of 1 only. Yes, q of 1. In the second case we got 2q of 1, and in the third case we got q of 1. So 2 plus 2 become 4. So 4 by 3 q of 1. Okay, so that means the right answer is option. Okay, so this is the way you have to solve this question. Be careful about taking the conditions. Now, let x of t is equal to a cos 2 pi f naught t plus theta be the random process where the amplitude a and phase theta are independent of each other and are uniformly distributed in the interval minus 2 to 2, 0 to 2 pi. And this is some other part of the question. X of t is fed to an 8-bit uniform quantizer and autocorrelation of x is given. That means the signal has the autocorrelation 2 by 3 cos 2 pi f naught t. Signal to quantization noise ratio we want to calculate. Very easy question. Signal to quantization noise ratio means we want to calculate the signal power, and power of the signal can be calculated by its autocorrelation, because the autocorrelation at tau equal to 0 will give you the power. So this is 2 by 3 cos of 0. When we put tau equal to 0, we will get signal power easily 2 by 3. Now we want to calculate the noise power. Since it is uniform quantizer, the noise power is delta square by 12. Now the question is, what is the step size? Now you can see that the PDF of x a and theta is given. So the PDF of x, or the signal value x, will depend on the value of a, because x of t is a cos 2 pi f naught t plus theta. So theta will change its phase, but a will give the amplitude of the signal. So we always quantize the signal, and when we quantize the signal, we get an error. That is known as quantization error. So what is the range of the signal? The range of the signal depends upon the amplitude of the signal, and the amplitude of the signal is a. So the PDF of a is minus 2 to 2, and the height is 1 by 4. So the step size is the highest value minus lowest value divided by quantization levels whole square divided by 12. The highest value is 2, the lowest value is minus 2 whole square divided by 2 to the power 2n, that is 2 into 8, because L is equal to 2 to the power n. L is equal to 2 to the power n. Number of bit is given as 8. So 2 to the power 2n, because we are squaring it, and hence we get this. And this one is 2 plus 2, 4, square 16. That means 4 upon 3 into 2 to the power 16. Now when we divide it, signal to quantization noise ratio, signal power 2 by 3, the noise power 4 by 3 into 2 to the power 16. So 3 and 3 will get cancelled, and this will be 2 to the power 15, which is 32,768. Correct? Yes. Now we want to calculate in dB. Yes. So just take 10 log 32,768. .15 dB. So right answer is 45.15. Okay, 45.15. Very easy question. Okay, so this one is the last question. The information bit sequence 1110100101 is to be transmitted by encoding the CRC, for which the generator polynomial is x to the power 4 plus x plus 1. The encoded bit sequence is. So here we have to first find the bit pattern by the polynomial. So bit pattern is, we can calculate it by x to the power 4 plus 0 into x to the power 3 plus 0 into x to the power 2 plus x to the power 1 plus 1. So this is having the coefficient 1. So the bit pattern is 1 0 0 0 1 0 0 1 1 1 0 0 1 1. The coefficient of x to the power 4 is 1 0 0 and then 1 1. Okay, this is x to the power 1 and then this is x to the power 0. So on. So the bit pattern we have got as this. Now we have to divide it simply. The number of bit pattern, the bits present in the bit pattern is 5. So we have to append the 1 less than the number of bit present in the bit pattern. So 5 bits are there. 1 0 0 1 1. Our original data is 1 1 1 0 1 0 1 0 1, and we have to append 4 zeros. Okay, because there are 5 bit present in the bit pattern. 1 less than bit pattern is are the zeros that we have to append in the transmitted data, and then we have to divide. So divide it 1 0 0. Start from the 1. Okay, so this is 0. So 1 1 1 and 0. Now take the first data here because we need 5 bits. So this is 0. Now starting from 1 0 0 1 1, we will have 0 here and 1 1 1 1. Then take this one. So you will get 1 0 0 1 1, and we will get 0 here, 1 1 0 0. Then take this bit 0. So we will get 1 0 0 1 1. 1 1 is 0. This is 1 0 1 1. Then take 1 0, and we will get 1 0 0 1 1. This is 1 0, and take 2 zeros from here. You will get 1 0 1 0 0 1 0 0 1 1. So we will get 1 1 1 and 0. Wait, I think there is a mistake. Now I don't want to rectify it in between, so I'm starting it again because of the space. Maybe let me check the bits again. 111 01 01 01, 111 01 01 01, and 4 zeros. Yes, so it is correct. So 1 0 0 1 1, we are getting 0 1 1 1 and 0. Okay, so this 0 we can ignore, and now I am taking this 0. So this 0 I am taking here. So now it is 1 0 0 1 1. So this 0 1 1 1 1. So this 0 we can ignore, and we will get this one. Okay, so this is the one. I think this is the place where I did the mistake. 1 0 0 1 1. So this is 0, this is 1, this is 1, this is 0, this is 0. And we need 5 digits now. So that is why this 0 is taken here. So now we have 1 0 0 1 1. So this is 0, this is 1, this is 0, this is 1, this is also 1. So this is ignored. Yes, this 1 should be there. So 1 0 0 1 1. So this 2 are 0, this is 1, this is 0, this is 0. So 1 0 0 we are getting, these 2 zeros we can ignore. Now we have to take the 2 digits. So 1 0 0 we will get, and then 1 0 0 1 1. So this is 0, this is 0, this is 0, 1 1 we will get. These 3 zeros will be ignored, and these 2 digits we have to append. Okay, initially these 2 digits are here. So these 4 bits are coming. So this is known as CRC, and this is the data which has to be replaced in this 4 0, and the correct data which has to be transmitted is the data plus CRC. So data plus CRC. What is the CRC? 1100. So 1101 111, this 1100. This is the 1100. Okay. So right answer will be option B. 1100 is the CRC. So from here only you will get. Otherwise you can also check 111 01 01 01. This is your actual data, and this is CRC. So data plus CRC is the correct encoded sequence. So right answer is option B. So thank you for watching this complete detailed solution of the GATE 2024, and stay tuned with us. Don't forget to subscribe our channel. Thank you.